Good morning, Jesse sir. जेन यसको प्रेडिक्सन के छ
सबै प्रिपेयर हुनुहुन्छ
मैले युट्युबमा हेरेको थिएँ जेन अनि जेन 15 मा चाहिँ यस गरेको अनि छिटो खालेछ है अनि जेन 29 मा चाहिँ एकदम
Hello everyone. It is requested you all please mute yourself during presentations and lectures. Everyone please take care of these things, okay? Thank you. Hello everyone. It is requested you all Hello.
Good morning.
Good morning. Got it.
Good morning, madam.
Good morning, sir. Good morning.
गुड मॉर्निंग टू यू ऑल। आशीष जी, तेजस जी, नमस्कार।
नमस्ते सर जी।
कैसे हैं?
फर्स्ट क्लास सर, एज यूजुअल।
ओके, गुड। सना मैडम,
या गुड मॉर्निंग।
जय हिंद। आशीष जी, कैसे हैं? बढ़िया।
हाँ हाँ बढ़िया।
चलिए, बहुत दिनों के बाद फिर दर्शन हो रहे हैं। I think after 5 minutes we will start the session.
Sure.
भावना,
अच्छा, 5 मिनट्स बाद स्टार्ट करें।
लोड ले रहे हो।
भावना, भावना,
after 3 minutes we will start the session.
Yes, ma'am.
Rajesh Pandit sir, I think is also connected. Mr. Rajesh Pandit.
करो। Got it, करो।
Hello, Asthana ma'am. Hello, Asthana ma'am.
हाँ,
Ma'am, there is a background noise from your side. Yeah, it's okay. Fine now.
भावना, I am इसको leave कर दो। भावना, am I audible?
Yes, ma'am.
But
Yes,
Can I
ma'am.
start?
Yes, ma'am.
A very good morning. Am I audible?
Yeah, ma'am. Too much background noise.
Okay.
Yeah, ma'am. It's fine now.
Bhavna, some network problem is there.
I'm already muted, ma'am.
Possibly two devices are connected at a time.
Is it okay, ma'am?
A very good morning.
आपके पास दो सिस्टम है, मुझे लगता है ऑन है।
मैम के पास होगा सर, आई एम आउटसाइड।
हाँ, मेरे पास होगा जो ऑन है।
इसमें लेट कर दो। A very good morning.
Ma'am, you are muted.
A very good morning. Okay, sorry. A very good morning and a warm welcome to all. On this second day of our virtual conference, I, on behalf of organizing committee, extend my warm welcome and a special thanks to our all invited speakers, Dr. Rajesh Pandit from Tribhuvan University, Kathmandu, Nepal, Professor Ashish from IIT Kanpur, Professor Sunita Savaria from Government College, Surajpur, our jury members and our session chairperson, Dr. Tejas Joshi from Bhavnagar University, Gujarat, all delegates and dear participants. I welcome one and all, and today we have 3 invited talks by eminent speakers and thereafter oral presentations by students. I request you all participants to get involved and extend my sincere thanks once again to invited speakers and jury members. I request Madam Bhavna Jain to introduce Dr. Tejas Joshi. Over to you, Bhavna.
Thank you, ma'am. It is a matter of great privilege for me to introduce Dr. Tejas P. Joshi. He has such a remarkable feather to his cap that no introduction would be apart his actual virtues. Dr. Joshi is presently working in Department of Chemistry, MK Bhavnagar University, Gujarat. His core area of research interest is nanomaterial and micelles. He has multiple research publications and the list is very long. That will increase his profile. He has conducted various minor and major research projects and he has visited many countries like UK, Canada, Malaysia, Australia, Singapore, etc. So list of countries is very long. So it's my pleasure to welcome sir to chair the session. Sir, please.
Thank you very much for a nice introduction. Good morning, everyone. Am I audible?
Yes, Tejas.
Yes, sir.
Thank you.
Good morning. Good morning, Dr. Joshi.
Thank you, madam. Thank you, ma'am. Okay, first of all, I'd like to thank the organizing committee as well as Professor R.N. Singh, sir, Professor Asthana, madam, Professor Alka Tiwari, Dr. Sunita, and special thanks to my dear friend, Professor Ajay Singh, for providing me an opportunity to act as a chairperson in today's session. First of all, I did like to welcome everyone, including the keynote speakers. Before starting our session, I like to add that, again, I'm repeating that there are 3 renowned speakers from our sides. There is a minor change in the schedule, what is printed in the book brochure. The first keynote speaker addressed by Dr. Rajesh, then followed by Dr. Ashish, and then Dr. Sunita. Each will speak for around 30 minutes, and then after a regular question answer will be scheduled. Before inviting Dr. Rajesh Pandit, I like to give small introduction about him. Dr. Rajesh Pandit is currently serving as an assistant professor at Tribhuvan University, Kathmandu, Nepal. He did his PhD in polymer chemistry from Central Department of Chemistry, Institute of Science and Technology, Tribhuvan University, Nepal. His research in area are polymers, nanomaterials, block copolymers, etc. He has published more than 16 research papers in reputed, well-indexed paper journal. He is also acting as a president of Nepal Polymer Institute. He served as a reviewer in many journals such as Journal of Nepal Chemistry, Journal of Chemical Education, Journal of Chemistry, etc. He is also active participant and involvement in IUPAC related activities and has represented as a national representative and held in meeting takes place either in Korea, Brazil, etc. So list is very long, but due to the constraint in time, I would like to welcome Dr. Rajesh Pandit. Dr. Rajesh Pandit, are you available?
Yes. Yes.
Okay. Welcome, Dr. Rajesh.
Okay. Very good. Good morning.
Good morning.
Thank you, Chairman, for your nice introduction. I would like to thank Professor Dr. A.K. Singh for the invitation. Likewise, I would like to thank Professor Anupama Asthana and other colleagues for the opportunity to present my work in this platform. Today, I'm going to talk about the. Can I share the screen? Yeah.
PowerPoint is not visible.
Is it okay?
Yes, it is visible.
Okay. Okay, then the topic of my today presentation is a physiochemical characterization of starch-based bioplastic. And I would like to give the overview of my workplace. I am working at Trichandra Multiple Campus, T1 University. This is located at the center of the city. You can see the location map of this campus, which is near to the. It is the middle in the city and near to the T1 International Airport also. Not far from this international airport also, and this is the college premises, and this college was established at 1980. It was more than 104 years old campus, and about 12,000 students are studying in this campus. This is the classroom where the students are studying in the classroom. Okay, this is about the short introduction about my workplace. Then I would like to move toward the my presentation outline. These are the outline of my presentation. I'm going to introduce about these biomaterials, bioplastics, and how they can synthesize the bioplastics, and their after that their characterization in a different way. Then now I would like to move the general introduction. As you all we know, the polymer, that is the polymer is made from the monomers by the polymerization process that form the long chain polymer, and the unit is monomer unit is combined to each other by the polymerization process to form the polymer. And the polymer generally classified by the basis of the sources that may be natural, synthetic, and synthetic polymers. Besides these classification, that can be also classified as a biodegradable and a non-biodegradable polymer. And I would like to talk about the biodegradable polymer as a plastic, and that is made from the traditional petrochemicals, which are engineered to break down more quickly. That may be the polyglycolic acid, polybutylene succinate, that may be the example of the biodegradable plastics. And bio-based plastics are another types of the polymer that is also made from the natural material, such as corn starch, lactic acid, cellulose, etc. And some of the example is polylactic acid, PLA, and starch blends, etc. And then when we move forward, the starch-based plastics, which are mainly the functional group contain as amylose and amylose pectin. The structure, the chemical structure of amylose and amylose pectin is shown in this slide. Now move toward the further bioplastics. The bioplastic, which are derived from the various biological sources, that may be the bamboo cotton, potatoes, mango skins, banana peels, and brown cells, etc. And that it is also the renewable resources for promoting green technology, and the materials are inexpensive and environment friendly too. Further, some of the popular materials which are synthesized from the bioplastic that is shown in this slide, which are the disposable tableware to the flexible packing materials. They are synthesized from the bioplastics. Now, the starch-based bioplastics, which can be synthesized by the waste materials such as banana peels and potato peels, they are short-lived and environment friendly, and which can be used for our daily life, for the material used in the as a household property. Now, then the objective of this study is to fabricate the starch-based bioplastic films from the banana and potato peels that can be characterized by the FTIR spectroscopy, and after that, that can be used to investigate the biodegradability and water absorption property. After that, to obtain these objectives, that can be used to prepare the materials by following the synthetic routes. For the in the synthetic route, we have used the materials that may be, that are the banana and potato peels, and urea, glycerin, and glucose as a plasticizers, and HCl and NaOH as a reagent, which is used for the preparation of bioplastic. The method is the preparation of banana and potato peels paste by mechanical grinding and preparation of bioplastic film. For the preparation of banana peels paste, banana peels were chopped into the small pieces, soaked in benzoic acid for about 30 minutes, boiled the pieces of banana peels in distilled water at about 30 minutes, and decanted and left for dried, followed by grinding to paste. And these are the steps involved in the preparation of banana peel paste. Likewise, the preparation of bioplastic, about 25 gram peels paste was mixed with 3 ml 0.5 NaCl and stirred with glass rod, and about 2 ml urea or glycerin plasticizer was added to the mixture and stirred. The mixture was filtered and poured to the petri dish and heated about 130 degrees Celsius for half an hour. The sample was dried in air for 3 to 4 days. Likewise, the composite can be prepared by adding the chitin and chitin hydroxide composite with the above mentioned procedure. And this figure shows the preparation of bioplastics. This is the bioplastic we can obtain after the preparation of by following this method. Now, this can be characterized by using FTIR spectroscopy and further investigate water absorption test and soil decomposition test. Now, move toward the structural and functional group analysis. To analyze the functional group in the prepared bioplastics, in this slide, you can see the different spectra, which was prepared by using the different plasticizer. The plasticizer, that is distilled water, glycerol, and glucose and urea. These plasticizers were used for the preparation of bioplastics. The spectra, all of the spectra are shown here as a comparison with each other. Then there is no any difference in the spectra. Mostly the spectra we can see at about 32 to 3300 range, that is that represent with the hydroxy bond formation, and about 1920 per centimeter that represent the CH stretching of CH2 group, indicate the amylose and amylopectin, and about 1598 per centimeter C double bond O vibration indicates the amide first region, or 1024 per centimeter, that is the CO indicates which is the hydroglucose ring. And these after these FTIR spectra analysis, we can see that the starch-based bioplastic can be synthesized by using the different plasticizer. Now, similarly, we can see in this slide by using the using the potato starch as compared to the commercial starch, the similar peaks can be seen here as already explained in the above slide. Now, then move toward the another result and discussion, that is the plasticizer variation. In the plasticizer variation, we can test it the material as a water absorption property or water uptake test. For this water uptake test, we can see that the weight gain versus time plot, the different plasticizer sized bioplastic, that is glucose plasticized bioplastic and distilled water based bioplastic, urea based bioplastics, and glycerol based bioplastics. The glycerol based bioplastics shows the higher water absorption in comparison to the other plasticized materials. Then the water gain is higher in glycerol plasticized bioplastic than urea based bioplastics, whereas lower water uptake shows the glucose based bioplastics. Now, the soil burial test for the different plasticized plastic also shows the result. The glucose-based bioplastic shows the low decomposition pattern in comparison to other plasticized-based bioplastics, and it took about 80 days to degrade the bioplastics. Mostly all of the bioplastics shows the similar trend, whereas the water uptake or soil weight loss is less in the distilled water based bioplastics in this soil burial test. Now, to conclude about this session, this topic, the starch-based bioplastics was successfully fabricated using urea, glycerol, glucose, and distilled water from the banana and potato peels. The FTIR spectrum indicates that the amylase and amylopectin contain starch linked by amide and hydroxyl with hydrogen bonding interaction to the plasticizer. Low concentration of plasticizer containing bioplastic film absorb less water. As the concentration increases, the water absorbability increases. Then now to the concentration of the variation of plasticizer, the concentration based bioplastic also the water absorbability test can be seen here. The weight gain versus time plot shows that the pure plasticizer which is used, that weight gain is higher in comparison to the lower concentration of the plasticizer. The concentration, only one normality of the plasticizer shows the low weight gain in comparison to the pure plasticizer. This trend shows that the water absorption capacity is higher in pure plasticizer, that is glycerol, and after that 20 normal plasticized glycerol, then after up to the 1 normality. Then now similarly move toward the biodegradability test as that is the soil burial test. In the soil burial test, we can see that the pure material was degraded fast as compared to the one normal plasticizer used in the bioplastics. From this, we can say that the glycerol plasticizer encourages the interaction of bioplastics with water and increase the concentration of glycerol and starts enhance the biodegradation. Now, the blends bioplastics with PBA. In this result, I would like to talk the blend with the starch PBA blend bioplastics, where the PBA, pure PBA has very low water resistance capacity, and only they are disintegrate after 2 hours. And in the different ratio of starch PBA combination blend, the starch is starch PBA combination, that is 1:4 ratio, 2:3 ratio, and 3:2 and 4:1 ratio is shown in this plot. You can see the starch and PBA is 4:1, shows the water gain capacity is low, and which remain up to the up to about 50 hours in the water absorption capacity. Similarly, that is also soil burial test can be seen of this blend. The blend shows follow the trend where the PBA shows the higher higher water gain, that after the weight loss of starch PBA 4:1 is low, and that also degraded very fast within 40 days. Now, from that, we can conclude that high concentration of starch in starch PBA bioplastic has greater water resistance, and the soil burial test, in soil burial test, higher amount of starch decrease the biodegradation in starch PBA blend. Now, the last of the result, bioplastic nanocomposite. The composite prepare with the bioplastics. First of all, we tested with the chitosan as a material nanofiller that enhance the degradation time. It takes about more than 80 hours, and that's why taking the advantage of this nanofiller, we practice it with the composite, that is chitosan and hydroxyapatite nanocomposite. That is also took with the bioplastics to form the bioplastic in different weight percentage, and that chitosan HAP nanocomposite was taken into 10% to 50% weight ratio. From that, we can, from this plot, the water uptake test plot, we can see the weight gain versus time plot, where the 50% Chitosan HAP nanocomposite shows the low weight gain in comparison to the 10% of Chitosan HAP nanocomposite of bioplastics. Now, the soil burial test is also performed to the same materials, where the 58% materials can get the low weight gain in comparison to the 10% of the Chitosan HAP nanoparticles. Chitosan HAP nanocomposite in the bioplastics. Now, I would like to conclude that the addition of chitosan filler in the urea plasticized starch based film enhance the water resistance property of film. CS HAP nanocomposite higher the amount of composite, lower the water absorption capacity. The in soil burial test, higher amount of chitosan HAP composite shows the faster degradation, decays slowly after after 15 to 17 days and degraded within 2.5 months for the above materials. I would like to thank the University Grant Commission for providing the dissertation grant support to Ms. Sunita Rizal, and I would like to thank my master's thesis student, Ms. Sunita Rizal, Mr. Khagendra Chapai, and Binod Shrestha. I would like to thank Dr. Savita Shrestha and Khagraj Sharma, Central Department of Chemistry, for their assistance with EFTR spectra, and I would like to thank organizing committee IRTSD 2021 for this opportunity. Okay, thank you.
Thank you, Dr. Rajesh Pandit. I'm thankful to you as you finish in time. The session is open for 2-3 questions. If someone have any question, please ask Dr. Pandit.
Sir, here Dr. Bhavnajan, I want to ask some question to sir.
Yes.
Good morning, sir. As your topic is very interesting and beneficial for society, so I have a few questions. That in method, you have mentioned that you have added benzoic acid to the banana peel or potato peel. What is the actual role of benzoic acid, or can we substitute it?
Instead of benzoic acid, we can use another reagent too. That is generally that is used for the instead of this, we can also use sodium. Sodium hypochlorite, like that.
Okay,
and this benzoic acid is used for to prevent the material from the fungus growth, or that is used as a protective, and that also used as a that I forgot the bleaching action. The bleaching action can be done by sodium hypochlorite, and that is benzoic acid used for as a to protect from the fungus growth.
Okay. Sir, another question is that plastic is a petroleum product.
Yeah.
And you have mentioned that you have used degradation, soil degradation, and other FTIR and all. Is there any particular test to confirm that our plastic is completely prepared or not prepared?
we have only did the FTIR and other FTIR technique only, and we did not characterize by any other technique.
Okay, sir. Sir, in your graph, you have said that after adding plasticizer, the absorption capacity is changed. I just wanted to know, did you increase the glycol content in complete material, or you have started from that? I'm getting a little bit confused. That's why I'm asking.
The material which is prepared by using the different concentration of the glycerol, 1 to 20 normality of glycerol was prepared, and only without that pure glycerol also used without any mixing of water. That is also taken to the experiment.
No, sir. I'm asking that did you add that banana peel and all things are there, and you have changed the glycerol content only from 1 normal to pure, or is it only that plasticizer?
That is the used as a plasticizer,
Yes.
and also tested as a different concentration of a plasticizer, the material.
Okay. Thank you, sir.
Welcome.
Dr. Pandit.
Yeah.
Most of the bioplastics and plant-based material contain some toxic materials, especially in starch and in vitro activities. Is there any way to overcome this?
Yeah. Pardon?
Bioplastics are available from plants, generally starch or cellulose. They may have some toxic properties that is found in vitro. So is there any way to overcome this toxicity?
No, we did not work on about that. Only we tested that is the material which can be developed if we materials for the daily uses as a packaging materials, baggage instead of polymeric materials or that plastics. Polyethylene, instead of that we can instead of that substitution we can develop the bioplastic for our daily uses that can be reduce the use of polyethylene etc.
Yeah, but generally polyethylene purpose is for the food packaging. So it is very concerned about the materials or additives which are used for this synthesis.
Yeah.
It is not toxic.
Yeah. But we did not test it about the toxicity of the materials.
Okay, sir. It is a very nice informative lecture. Thank you, sir.
Okay, thank you. Thank you very much.
Thank you, sir.
Okay.
Sir, close your sharing. Okay. Now, before calling Dr. Ashish Gupta, Dr. Ashish Gupta, are you available?
Yeah.
Okay. Thank you, sir. Okay, I have a brief introduction about Dr. Ashish Gupta. Dr. Gupta did his PhD in chemistry from University of Allahabad in 2004. Then, after working in Nagoya Institute of Technology, Japan, he moved to SCDT IIT Kanpur in 2007. He worked for SCDT as a research engineer from 2010 to 2015. Then, since 2015, he is working as a senior research engineer, or you may call as a team leader in National Center for Flexible Electronics at IIT Kanpur. His research interest is in functional ink for printing and flexible electronics. Research areas include surface chemistry, supramolecular chemistry, material characterization, nanomaterials, polymers, etc. He has published more than 25 research articles in very reputed journals. So now I call Dr. Ashish Gupta. You have 30 minutes.
Yeah, thank you, Dr. Tejas, for your introduction.
Thank you, sir.
I would like to thanks organizing committee for their invitation. So I'm sharing my PPT. So yeah, so I'm working as a team leader here in National Center for Flexible Electronics, IIT Kanpur. And my area of working is that printable inks for flexible electronics. So this is a outline of my talk. And before I can start telling my presentation, let's introduce about the flexible electronics. What is flexible electronics? So flexible electronics is the electronics on the flexible substrate. And on the flexible substrate, there is only one way to do the flexible electronics is through printing. So the main motivation of having on the flexible substrate and through printing is that to have a low cost electronics with high throughput. And one can make a disposable electronics in a faster and cheaper way. That is the way one can produce in a large scale with high throughput. So flexible electronics can be done on different substrate like paper, textile, plastic, metal foil. These are the substrate where one can do the flexible electronics. And why it is printed and why it is flexible. There are few examples of that, like solar cell. We know that all the solar cell are made of silicon and on the silicon substrate. So with the printed electronics, there is a envisage that one can have a roll-to-roll, means kilometer kind of solar cell can be printed on the paper or plastic substrate, and one can lay out on any surface or roof with the solar cell and have that advantage. Yeah, there is no comparison between the solar cell of on silicon, but definitely cost wise, if you can compare, it is much lesser price you can produce in a large scale. Another example is that solid state lighting. You can print it on the PT substrate or paper substrate, this lighting. Yes, there is a lifetime issues with this thing, but technology is still in the development phase. With the time it will mature, then we will have those kind of application. Smart tag means having NFC and RFID within this tag that can also be printed. At this moment, all the RFID tags are made up of Irtst foil, but it is envisaged by additive printing on the substrate. And there are certain diagnostic tools also can be made by printing, like glucose strip can be printed, and that electrodes and rest of the things can be printed, and we can have a roll-to-roll printing on these kind of devices. Flexible display, all of you know that many companies are making this displays. Yeah, there is a issue of reliability and with time it degrades, but definitely it is coming in the near future. And there are security tags, like one can have a security tags on the, like for example, on the liquor bottles, people are making, government is making security tags. That all can be printed on a large scale with on the roll-to-roll machine with a high throughput at a cheaper cost. So what are the challenges for making this kind of devices? One is that inks. When we talk about the printing method, there are combination of different printing method can be used. Sorry. there are different printing method can be used for making this kind of products. And that all printing method required a different kind of inks, and required a particular method for a particular printing process. We need a specific inks for those printing methods. So there is a key challenge of making inks for that particular printing method. Not only a variation in the in a different type, but a very specific kind of printing ink formulation is required for printing process. Like for example, inkjet is we know that all the desktop are nowadays inkjet, but there are different technologies used in inkjet, like drop on demand DOD and thermal jet. Most of the Canon based inkjet printer are based on the thermal jet, and most of the HP based desktop printer is all drop on demand. So for ink formation for both the different desktop is different. So flexible electronics, what we envisage the different different devices which required a different kind of inks, like conductive inks, semiconductor inks, and dielectric inks. These in combination, mostly all these devices can be made by these combinations, conductive, semiconductor, and dielectric inks. Within this conductive inks also, there are different conductive inks made up of metal complexes, flakes, nanoparticles, and polymers. And there is one more variation of this conductive inks is made up of carbon-based materials like graphene-based or CNT-based inks. So different materials having different pro and cons of this material. We'll talk in the later of this presentation. And there are semiconductor inks. Basically, most of the active layer is made up of this semiconductor inks, and this is made of polymer or oligomers, small molecules, or any functional materials. And dielectric is majorly used for making TFTs, and basically this is insulating materials, and basically it is made up of either inorganic materials or a combination of polymer and inorganic materials. So we'll talk about the conductive inks materials, which is mostly based on the nanoparticles, flake based. Most of the commercial ink is all flake based materials, but there are a few examples. You can see metal organic based also available. And basically carbon based inks. This is a less conductive materials. Mostly resistive inks are made by the carbon materials. So here is a comparison of different kind of materials with the performance, and the kind of resistivity you can achieve by the printable inks is that like metal nanoparticle inks, you can have a very high performance with very low resistivity. With CNT based things, which is 10⁻⁻1 to 10⁻⁻2 kind of resistivity, and micro powder based paste, you can achieve 10⁻³ to 10⁻⁴ ohms centimeter of resistivity. But nowadays, if you can see the commercial inks, which is either based on the flake, or there is a combination between the flake and the nanoparticles. And the polymer ink and carbon based graphene inks nowadays, the trend is coming people are working with a high conductive carbon. They are achieving kind of 10⁻⁴ to 10⁻⁴ to 10⁻⁵ ohm centimeter of resistivity. So basically the coming era, future era will be of carbon inks. So what kind of challenges for this kind of materials, that having a good dispersion and the prevention from the aggregations, because when you make it materials, it aggregates very fast, and having a low polymer content with high metal content, and there should not be any process variation when you make chemically. There is a lot of batch to batch variations observed, and this polymer create a lot of insulating layer between the metal particles. So we should have a less amount of polymer, and this polymer is used as a caping agent. So we have to reduce it as less as possible for this kind of metal conductive inks. And oxidation is one of the challenges to prevent this kind of nanoparticles. When you make a nanoparticles, surface area increases, and those particles are very prone to oxidation. So in that ambient conditions, so we have to protect it through this oxidation. That is also one of the challenges. And when we talk about the cost and all these things, silver is definitely it is a very high conducting materials, but the coming trend is that to change with replace it with copper and aluminum. But there are a lot of challenges of having aluminum and copper as a conductive materials for in the printable electronics. These materials are very prone to oxidation. So there are method of making materials for conductive inks. Is that one of the method which is a top-down approach. Top-down approach is that bulk materials can be milled, and that can be converted into a flakes materials, which is having a certain advantage, which is if you can create, if you want to create in a bulk materials, then it's an inexpensive process, and a large scale process is all possible with this top-down approach. And there is a certain disadvantage also with this material, that creates a lot of internal stress of this in this materials, and having a large distribution, controlling the distribution of size is very difficult to achieve in this thing. But bottom-up approach is that mostly chemists adopted, and there are advantage and disadvantage also of this process as well. And disadvantage is that batch to batch variation, and when we go from lab scale to production scale, that will having batch to batch, a lot of batch to batch variation. So basically in this method is that basically a reduction and kind of nucleation growth, and controlling nucleation growth, one can achieve a definite size of the particle, different morphology of the particles. And this is the challenge to control this nucleation process of this nanomaterials. So here are the few examples of the materials. Is that gold nanoparticles. Gold nanoparticles can be capped with certain thiols, which is a very well adopted process, and this is called a breast method. And one can achieve a good material, very small size of particles, and with having a different thiol chain capped materials. And there are certain other options also, like one can use a different kind of polymers can be used to cap those kind of gold. And mostly this kind of materials can be used in the inkjet formulations. So silver is also one of the choice of materials, and this can be reduced in the silver nanoparticles. And the kind of material, this kind of size you can achieve with these materials, that can particularly for based on the requirement. And the inkjet required a small size of material, like less than 50 nanometer of size. If you are able to achieve it, you can make inkjet materials. Otherwise, the size of the particle is around 500 to 600 nanometer. One can go for the screen printable inks. And copper is also a material of choice for this kind of conductive inks, but there are a lot of challenges to make the copper nanoparticles with having a lesser capping agent. And because copper is very prone to oxidation, it oxidizes very, very fast. And even if you are able to protect it in a nanoparticle formation, while sintering it, it will oxidize and give a copper oxide, which is insulating. So one can achieve like more than 97% of metal loading can be achieved for means approximately 3% of polymer can be used for capping agent. This is one of the example what we have done so far. The kind of material which is required for inkjet to screen. See, these are the two extreme of the as per the requirement of materials. Is the inkjet is required a small size of particles like less than 100 nanometer, and a screen which can have even 1 micron of the particle is okay for that. And there is a fluxo and gravure requirement as in between this inkjet and the screen. And metal loading, definitely we required more than 90% or 95% of metal loading is required, and less than 5% of capping agent should be there. And material loading in the ink is in inkjet basically is 25 to 30%, and in the screen it's more than 60% is better for screen printable inks. So how ink is formulated? That's an important thing to understand how ink is formulated, because ink is a when you make ink, it's a combination of many parameters. And when you are making inks, the printing process, one has to understand the printing process, the kind of particle size requirement for this printing process. And there are lesser amount of polymer should be there. Here, all your printing parameters is come from this resin. Resin defines most of the parameters, and resin is an insulator, is as a polymer. So we have to play between the resins, your particles and the capping materials. And when you're able to disperse it into a solution, then you have to play with the additives, which is basically a rheological, defines the rheological parameters of your ink. And the printing process is very particular about the ink formulation or ink rheology. So this is a very complex process. We have to take care of all the parameters which is listed here to make it into a formulation which can be printed. So if you are able to make materials, then nanoparticles, and the first step which can be used is that solvent to make it disperse. And to remain it disperse in a solvent, one has to use a binder, or maybe it can be use your capping materials may act as a binder. So there is a combination between binder and capping agent, and mixing with the additives, and that makes a conductive inks, and that can be printed through either of this printing process. So there should be a metal particles, metal nanoparticles, solvents, co-solvent, binders, additives, and mixing. So these are the combination of things which is used in this making conductive inks for this particular printing process. And if you compare between the inkjet and the screen, that inkjet required a lesser amount of materials, but should have a higher metal loading and more material loading, but lesser the polymer loading should be there. And a binder should be not more than 2 to 5%. Otherwise, it will not sinter well and will not give you a conductive line. It will give you more resistive line. So the ink requirement for inkjet printing is that size should be less than 100 nanometer or 50 nanometer, depending upon the size of your nozzle. And the viscosity is also, it is giving a range of 1 to 30 centipoise. It will also depend upon your feature size and your nozzle size. And surface tension, which is roughly 32 dynes per centimeter. And the jetting parameters which is required is that Z value is 1 to 10, and Ohn-Soge number is between 0.1 to 1 for a good jettability. And the printhead is having a different nozzle and different volume can be ejected depending on the printhead, and having different printhead, having this more number of printhead will give a larger feature size. And if you want a smaller feature size, you should have a less number of nozzle. And basically this will give you less than 500 nanometer of layer thickness. Yeah, so for screen printing, the requirement is that either one can use a flakes or nanoparticles, or in combination of these flakes and nanoparticles. And size should be basically it's 1 to 2 micron, but there is a lot of variation also depending upon your mesh size. And larger the mesh size, more the opening, larger the material size, you can use it. And this is also having a very large window of this viscosity range. 500 to 50,000 kind of centipoise of viscosity can be used for this kind of printing. And surface tension is also around 32 dynes per centimeter. But definitely a layer thickness with this screen printing is larger in comparison to inkjet. And feature size is also larger, 20 to 100 micron. And the feature size is all controlled by selection of your mesh size. And the larger the mesh size, mesh number of your screen, you can achieve a smaller amount of feature size. A small feature size you can achieve. I will skip this thing. There is substrating interaction. There are 3 different type of substrate. And one is porous, which is having a paper is the example of this porous, and semi-porous substrate, which is having a glossy paper coated with the polymer. And third is that non-porous, which is plastic and PI. And all these 3 different substrate required a different formulations. So like, for example, if you are preparing ink in the water-based preparation, it will not wet your PET substrate. It will wet a paper substrate, but it will not wet the plastic substrate. So the substrate is also defines the kind of formulation you want to make it. And there is another part of this printed electronic is that the kind of print sintering. So sintering is basically a different kind of sintering, but mostly the thermal sintering and IPL sintering is the most common in the printed electronics. So let's understand what is the sintering process. Sintering process is basically kind of melting of this nanoparticles in a small size of nanoparticles, melt and combine each other and make a conductive path. And more and more sintering happen of these materials will give a better and better conductive of your materials. lesser the sintering process happened, it will give a restive path of your printed layer. So how it happens, we know that when you make a nanoparticles, when like bulk of gold having a melting point of 1064 degrees centigrade, when we convert it into a 1 to 2 nanometer of size, the melting point reduces to 153 or less than 160 degree centigrade. And the important part in the printed electronics is that when we are printing on the flexible substrate, mostly plastic substrate, so that plastic substrate sustain not more than 160, 170 degrees centigrade. So we have to keep our sintering process such that your plastic doesn't melt during the sintering process. So here is the live example. You can show this video that how this gold nano ink is converted into a conductive path when you heat it on the your hot plate. And this number is the temperature which is connected with this hot plate. And the temperature increases, this will convert into a shiny golden color. So this gold ink is, you can see this is a black color, and when it is heated up, it will convert it into a golden color. So the temperature is increasing here, and it will slowly, if you can see here, the lower part of this thing is started converting at 130 degrees centigrade. So you can see that even in 130 degrees centigrade, 140 degrees centigrade, it started converting. And this will be completed at 153 degrees centigrade. So if you can wait it for 155, 156 degrees centigrade, it will completely converted into a gold line. You can see the lower line is now it is converted into a golden line. So another printing sintering process is that IPL, intense photon light sintering. So in this thing, what happens is that nanoparticles absorbs because of SPR, and there is an intense photon light is shine on your materials, and it absorbs, and local temperature increases, and that leads to a sintering process happen, and it nanoparticles melts and connected to each other and converted into a conductive path. So I will skip this part. Yeah. So before we can go to see the certain examples, so there is a complex process involved in this to envisage this printed electronics. There is a ink compositions, printing process, substrate, and there is a curing process, which are all interdependent to each others. And if you vary one of the process, that will alter another your process. So I will show you a few examples. What we did in this area is that this is a metal printed line made up of copper materials, and this is printed for this membrane switch. This can have a application on the membrane switch. And this is another example of printed heater, which can be used in the wearables. And this is a OLED stacks. One can print it this OLED lighting. So summary of my talk is that one can make a stable materials for conductive inks and can be tailored as per the requirement of ink and process. Ink can be formulated for different printing technology, and desirable conductivity can be achieved by manipulating materials and formulation and appropriate sintering process. Thank you. If you have any question, please.
Thank you, Dr. Ashish. Now the session is open for quick 2-3 questions. So anyone have any questions? Sir, most of the ink which are currently used are based on metal nanoparticles. So is the only reason that because of resistivity, we are replacing the organic as well as other metallic ink?
Sorry, I didn't understand your question.
Sir, most of the conducting inks which are now which are made are generally metal nano-based particles, metal nanoparticles. So is the only one reason of resistivity we are replacing the organic as well as metallic ink?
First of all, most of the commercial ink is also all made up of metal flakes. That is not metal nanoparticles. But nowadays people are seeing that mixing this metal nanoparticle with flakes is having a better result. And because see the metal nanoparticle having one disadvantage, but is that is capping agent. Capping agent is mostly polymer, and that is insulating materials, right? So that insulating materials create lot of resistivity, more resistive than this conductive. So in the sintering process, you have to remove this your polymer which you have used in this making that materials. So that is very important when you are using any polymer like binders or even the capping agent. You have to remove it to have a more conductive path of the splintered structure.
Right, sir. Sir, is there any research going on conducting paints?
Conductive?
Conducting paint.
Yeah. Yeah, there are a lot of research. We are also working on this conductive paints. We have developed certain products out of that conductive paints.
Okay, sir. Thank you, sir.
Thank you very much.
Okay. Thank you, sir. So kindly close your PowerPoint.
Yeah, thank you.
Okay, now a third keynote speaker is Dr. Sunita Sanwaria. Okay, before I handle the mic to Dr. Sunita Sanwaria, I like to introduce her. She is serving as assistant professor from a Deshbandhu College, University of Delhi. She did her MTech in Polymer Science from Central for Polymer Science and Engineering, IIT Delhi in 2009. She did her PhD from Department of Textile Technology, Indian Institute of Technology, Delhi. Her research area or interest includes nanofibers, synthetic, nanotechnology, etc. She has published her research work in very high impact factors. She successfully supervised 3 major projects. She also bear one Indian patent on solvent-free process of making a 3-dimensional porous scaffold. Hence, she is a very brilliant and a young dynamic person. Now I head over mic to Dr. Sunita. Sunita, you have 30 minutes.
Thank you, Dr. Tejas, for the nice introduction. Am I audible to all?
Yes, you are audible.
So I thanks to the organizing committee for organizing such a nice platform for the young minds to have a very brief look on how the recent research is going on. So without taking any time, I would like to share my screen. Is it visible?
No, not yet.
Now?
Yes.
Okay. So, okay. So I would like to discuss my research area with you all, and that is the functional hairy core shell nanofibers using the block copolymer self-assembly. So let us just have a brief introduction what the polymeric nano objects are. The polymeric nano objects is found to be used in a number of applications. For example, the drug delivery, where the drugs are loaded in the core or in the shell for the sustained release of the drug. Similarly, the other application could be the imaging applications. So here, in the past, polymeric nano objects were synthesized by the grafting approaches. And these grafting approaches make use of the condensation process, all the surface initiated and adsorption processes. These processes were successful, but in some cases, in some manner, they were very tedious, lengthier, and time-consuming things. So then we come to the next approach, which is the block copolymer self-assembly. Now, in this approach, we used the block copolymers. Block copolymers, they generally constituted of the two different blocks, and they have a covalent linkage between these two blocks. So what happens? These two blocks of the block copolymers, they actually do not like each other. So they tend to remain apart from each other. But also there is a tendency, there is a limit up to which they can remain apart due to the covalent linkages. So there is a tendency of these block copolymers to organize in some ordered fashion. So generally, at the higher temperature, they tend to remain in the random state. But as the temperature increases, they try to organize themselves in some geometry, some conformation, some orientation. So depending upon the volume fraction of the different blocks, A and B, we have different geometries. For example, if we have the 50-50% composition of the blocks, of the two constituting blocks, then we will be having a lamellar geometry. We will be having a lamellar conformations of the chains. But as the polymeric chain volume fraction is varied of these chains, so there is a formation of a radius of curvature at the interface of the two blocks. And due to the introduction of this interface at the interplanar region, the geometry changes and it takes that geometry that is more entropically and enthapically suitable for the blocks. Similarly, as we go, we further changes the fraction, volume fraction, we move from cylindrical to the spherical geometry. This can be understood from the graph shown here, where we have the polymerization and the volume fraction on the two axes. And as the volume fraction changes, degree of polymerization changes, the geometry of the block copolymer changes from spherical to cylinder to lamellar. Now this lamellar is the central point of the geometry. As we change the volume fraction from this 0.5 towards the higher ratio of any one of the block, the geometry changes. Geometry is also changing from left to right and right to left. Both ways, the geometry is changing. But the thing is that what domain is forming the core and which domain is forming the matrix. So the domain which is in minority is mainly constituting the domain, and the major block is forming the matrix of the geometry, matrix of the block copolymer. So this is the general overview of the block copolymer self-assembly, how block copolymers self-assembles themselves. So let us move to the solution approach. This particular approach, solution approach, make use of the selective solvent. Now this selective solvent, it is very good for the fabrication of the nano object, but all the geometries are not equally synthesized by this approach. This particular approach is very good for the micellar structure or for the spherical structure, because the range of volume fraction for other morphology is very narrow by this approach. So again, there is a need of another new approach so that we can get almost all types of the nano objects. So one of the interesting approach it is to use already self-assembled, the structures which is already self-assembled, and only we have to isolate the structures. So we make use of the selective solvent, but that selective solvent is that these self-assembled structures are so sensitive that even the solvent will disturb the morphology of the blocks. So then we came to the isolation of the bulk morphology by cross-linking process. In that case also we have used already self-structured, but illustration of the nanofiber isolation by bulk morphology, where polyisoprene and polystyrene, they are constituting the blocks, and they were microphasely separated. And these microphase separated structures, they were not dissolved in a selective solvent, rather they were cross-linked. Now by this cross-linking, the domain is fixed and the matrix is free, but free, it is not away from the domain, it is still attached by the covalent bond. So by any method, by chemical cross-linking or by the UV cross-linking or by the any other method, we have scientists have isolated the nanofibers. But this method make use of the cross-linking, which also make it a little lengthier and tedious process. So then comes the challenges for us, various challenges. The first challenge, it is to isolate hairy polymeric nano object from self-assembled block copolymer structure. And next is how to use these self-assembled structures for functionalizing the blocks, different blocks, either one block or both of the blocks, and how these can be used for functionalizing both of the blocks. So first is the synthesis of the self-assembled structure, then isolation, then functionalizing either block, and then both of the blocks. So this is the overview of the entire work, which I'll be going to discuss with you all. So here, the block copolymer is shown, the two different block copolymers are shown by the red and the blue color, which were self-assembled and were isolated in the form of cylindrical structures. Although we have also got the spheres also, but this research will be focusing on the nanofibers, nanorods, or the nanocylinders, whatever we may code them. I have quoted them as the nanofibers. Now, next is to use the shell, the blue shell, as the host for the functionalities. In the another case, I have used this core, red core, as to functionalize with the silver. And in the third case, I have functionalized both core as well as the silver, core as well as the shell with different functionalities. So let us come to the first section, which is the fabrication of the polymeric nano objects, nanofibers in our case. I have quoted this as a novel method because this has cut down a few steps of the already synthesized nanofiber steps. Here I have used the cylindrical forming block copolymer composition, polystyrene and polyphenol pyridine. The volume fraction is 0.3 for the polystyrene and it is 0.7 for the polyphenol pyridine. Polyphenol pyridine, it is taken by choice because we need to functionalize our block. So we need some group which is active towards the functionality. So we have chosen this nitrogen in the pyridine for our purpose. Now this block was dissolved in a common solvent and both the chains were well dispersed in this solvent. And they have well dispersed chains were left over as it is for some time, so that there is a ordered morphology is gaining. These block copolymers are gaining some ordered morphology by the time. Then the solvent was evaporated and this was dried, and the thin film was taken out of it. The thin film was in the form of microphase separated structures. These microphase separated structures now were dissolved in a selective solvent. Now we have used the selective solvent in this case as methanol, in which the polystyrene was not disturbed, but the chains of the polyphenylpyridine was collapsed over the polystyrene block. So this was the entire morphology which we were getting after the fabrication. And the block copolymers isolated were examined by a number of techniques. One such technique is small angle X-ray scattering. The small angle X-ray scattering shows a very small peak at 0.13 nanometer inverse, which shows that there is a microphase separation. Higher order peak at 1 is to under root 7. Two higher order peaks, that too in the ratio of 1 under root 7, shows the domains in the microphase separated structures were hexagonally packed. The small angle X-ray structure shows that we have got the hexagonal structures, and this particular result were further confirmed by the TEM of the bulk sample. So this next image is of the TEM, that too of the bulk sample. Bulk sample shows the axial as well as the cross-sectional view of the cylindrical domain, confirming the presence of the cylinder forming cylinders of the minority and matrix of the majority block. The results were later on confirmed by the transmission electron microscopy as well as by the SEM electron microscopy. This clearly shows that nano objects of around 70 nanometer length and length up to 2 micrometers were formed. SEM images are also shown here. Now, till now, we are confirmed with this that polystyrene is forming the core and polyphenol chains are collapsed over the cylindrical core of the polystyrene. Now, energy filtered TEM analysis was done over these nanofibers. This energy filtered TEM microscope results shows the signals of the different elements. Since we have polystyrene in our core, polystyrene is mainly made up of the hydrocarbons, hydrogen and the carbons, mainly carbon. So we have analyzed it for the carbon signals. The intense signals in the center shows the polystyrene core. And since we have in the periphery polyphenylpyridine, which have the nitrogen as major element, major significant element. So we have done the elemental mapping for the nitrogen. And the periphery is clearly shows that we have nitrogen in the periphery of our nanofibers. Now with this all results, we are now confirmed that we have polystyrene core and polyphenylpyridine as the collapsed chain over the core of the nanofibers. So this was the entire morphology of the nanofibers. Now, once we are clear with this morphology, then our next task was to introduce the functionality in the shell. Shell is composed of the polyphenylpyridine. Pyridine is very sensitive towards the functionalities. So we have used the gold and the cadmium sulfide. And in case of the metal oxide, we have used silica and the titania. But in the results only, I have been showing the silica. So this was the entire schematic illustration for the fabrication of the hybrid nanofibers. Till this step, it was the same as we have fabricated the nanofibers. So this diblock copolymer was dissolved in a common solvent that was slowly evaporated for the cylindrical, for the formation of the nanofibers, and these were then subjected to two different steps. The first is in situ and the next is ex situ. The first is solution approach and the second is substrate approach. So first let us see the in situ approach. Here the precursor auric chloride or the cadmium sulfide, the solution of the cadmium sulfide was dissolved in the solution of the nanofiber. The solution of the nanofiber was made in the lower ethanol, the lower alcohol. Then they were further treated for the formation of the nanoparticles over the nanofibers. This was the in situ method. Next is the ex situ method, where the fibers were first immobilized over the wafers, silicon wafers or the substrate, any other substrate. I have used the silicon wafer. And then they were loaded with the functionalities and further treated for the formation of the nanoparticles. So this is what we expected with our experiment. Let us see the results. So loading the functionalities in the shell, we are getting the gold nanoparticles, we are getting the polystyrene coal, we are getting the P4VP. This was a schematic, but this is the same pictures which shows that there is the formation of some silvery things, some shiny things, which shows that there is some deposition on the surface of the fiber. This was further examined by the TEM, which shows that there is some globules of the black color, and this is the crystallized structure showing the gold conformation. EDX was in support of the above results, which showed the strong signals for the gold. Silica is because we are using the silica wafer, so don't get confused with the silica result that we have not loaded the silica, but still this peak is coming. But this intense peak of the gold is due to the deposition of the gold over the surface. This was the UV analysis, which shows that we have got a very good peak, characteristic a peak at 470, which is due to the formation of, which is due to the deposition of the gold. This was the SEM and the TEM analysis for the cadmium sulfide deposition. The TEM shows that there is a polystyrene core and some deposition has occurred on the surface of the nanofibers. Then the lower images shows the EDX. EDX shows that we have a carbon signal. Carbon is due to the polystyrene core. Cadmium is due to the deposition of the cadmium, and sulfur because we have cadmium in the form of cadmium sulfide over the nanofibers. So this was the peak of the nanofibers with the cadmium sulfide on the shell, which shows the absorbance at the 370 nanometer, which is in accordance with the well documentation in the literature. Now, till now we have fabricated the metal hybrid nano objects. Now we are getting, we are focusing on the pure metal oxide nano objects. Here, the first thing is, again, we have used the block copolymer, same block copolymer. We have self-assembled these block copolymer. Then we have deposited the silica or the titania over the shell of the nanofiber because of the active group on the shell of the nanofiber. Then this structure was then calcined at the higher temperature in steps so that we get a hollow silica nanofiber or the hollow titania nanofiber. This is how we can extend our studies also. I have extended, but I will be dealing with the nanofibers in this stage. So this was the TEM analysis of the silica polymer hybrid nanofiber before and after calcination. So you can see that we have, before calcination, we have a polystyrene core, but after calcination, that core is not present. And the shell is somewhat widened due to the deposition of the silica over the shell. And this shell is somewhat thickened this shell is somewhat thickened due to the calcination, because there is some collapsion of the fibers also. So they were further analyzed for the formation of the silica polymer hybrid nanofiber before calcination, whether we have deposited our silica over the fibers or not. So intense peak, it's not the peak, but the intensity of this this white color shows that we have silica. Since silica is in the form of SiO2, so we have the O2 same picture as that of the silica, but this is an elementary mimic for the oxygen. And then we have mapped for the carbon. Since carbon is there on the in the core only, so we have carbon intense color. White intense color shows the carbon presence. Then they were further analyzed by the energy filtered TEM after calcination. This shows that we have a carbon signal. This is the normal fiber. This is the elemental mapping of the carbon over the nanofibers, which shows traces of the carbon. That means calcination has removed maximum of the carbon, but still some of the carbon has remained over the core. Now the figure C shows that silicon is there. The intense color and the oxygen mapping shows that oxygen is also there, which is most expected result. As per expectation, we are getting the result also. Now with this, we have introduced the functionalities over the shell. Now we come to the functionality, introduction of the functionality in the core, which is not an easy task because we have polystyrene as our core. And to introduce the functionality, we must have some active site, but polystyrene is not having any active site. So what we have used in that case, polystyrene coated silver nanoparticle. The particle was already coated with the polystyrene. Now, if that polystyrene coated nanoparticle is inserted into the polystyrene core, now the polystyrene will have the affinity with the polystyrene, but that polystyrene, the introducing polystyrene will have the nanoparticle inside it. So that will be easily incorporated into the core of the nanofiber. So this is the schematic illustration how we have incorporated. We have just added the polystyrene coated silver nanoparticle, and this was added into the polymer solution, block copolymer solution. The same polymer, block copolymer we are using, polystyrene block P4VP, which was then allowed to self-assemble. And this is the bulk assembly. This is the microphase separated structures. Okay. And these microphase separated structures were then isolated and spin casted over the substrate. And this is what we are expecting. This is our expectation that silver particle should go and arrange like this in the core of the nanofiber. Let us see. So this was the small angle X-ray analysis. Small angle X-ray analysis shows that the peak at the lower Q is no more here. This is because we have incorporated the silver nanoparticle inside. The core has swollen. So that Q range, that block copolymer showing the microphase separation has shifted beyond the range of the instrument. Now again, this red peak is for the polystyrene block P4VP, where we have under two higher order peaks in the ratio of under root 3 into under root 7, which shows that cylindrical morphology of the block copolymers is still intact, is still there in the morphology. And the two additional peaks at 0.9, 0.75 is there. And these peaks are due to the close packing of the silver nanoparticles inside the polystyrene cylinders. So with this, we are confirmed that we have silver nanoparticles in our system, and we have silver nanoparticles, but the cylindrical morphology is not disturbed. And that is a big achievement for us, that we are not disturbing the core morphology. And this result is with the 10 weight % of the silver nanoparticles. We have tried with the 4% also. We have tried with the 8% silver also. But the result with the 10% was excellent. This is the cross-sectional view of the silver nanoparticles which we have incorporated inside. But as we have moved from 10 to 15% weight percent, macrophase separation has started. This macrophase separation is disturbing the morphology. So up to a limit, the fibers are okay with the nanoparticles. So these are the SEM and the TEM analysis where we found that these nanoparticles are arranged in a special fashion inside the core of the nanofibers. This is the energy filtered TEM analysis, which clearly shows the mapping of the nitrogen, silver, and the carbon. Here the silver is very promptly shown. Here the nitrogen at the periphery and the carbon in the periphery. So let us come to the UV analysis. Here we have the SPM peak at 410, which was shifted to 480. That means there is a red shift. And that red shift, it is due to the nanoparticles which are closely packed in the characteristic manner in the core. So now we come to a very interesting analysis, that is the tomographic analysis of the nanofiber with silver nanoparticles. Now this tomographic analysis gives the three-dimensional view of the silver nanoparticles which were inserted in the core. Here we have a central chain of the silver nanoparticles along the nanofiber long axis. And this central particle was surrounded by 5 other nanoparticles by the stack of 5 nanoparticles, whereby adjacent rings are twisted by 36 degrees with respect to each other. Such twist of adjacent particles give rise to the helical arrangement of the nanoparticle. So such helical nanoparticle arrangement is very clearly obvious from this analysis. Now, we have added the functionalities in the core also. We have added the functionalities in the shell also. Now, next task is to make the multifunctional nanofibers. So this is the overall schematic of the multifunctional nanofiber fabrication. Here we have used the same fibers. We have used the polystyrene coated nanoparticles. We just have made the self-assembled structures. Then we have treated them by 2 methods, in situ and ex situ method, where we have used the solution approach to locate the the functionalities over the shell. And here we have used the substrate to locate the functionalities over the shell. So let us move to the results of this multifunctional nanofibers. The precursors were aurichloride and the cadmium acetate in this case. So we came to the TEM analysis of the nanofibers, silver, cadmium sulfide multifunctional nanofibers, where we have silver in the core and we have cadmium sulfide over the shell. The other images shows the crystallite structure of the cadmium sulfide over the shell. And this is clearly seen that the helical packing, this helical arrangement of the nanoparticles was not disturbed even after the location of the cadmium sulfide over the shell.
Dr. Suita, you have 3 minutes.
Okay, I'll try. So this was the EDX analysis, which shows that we have a carbon signals, we have silver because we have silver in the core, we have cadmium and sulfur also over the shell. This was the UV analysis. UV analysis makes sure that we don't have the peak of silver in our multifunctional nanofiber. And that is due to the masking of the SPR of the silver nanoparticle by the cadmium sulfide. So, okay, this was okay with us because we have 2-3 layers masking the silver nanoparticle. Now, then we have incorporated the gold over the shell. So this is the result for the TEM, and the crystallite structures of the TEM shows that gold has deposited over the shell of the nanofibers. This was the EDX analysis, And again, we have mapped the silver, gold, and the carbon, and the multi functional nanofibers in the EDX. Then we have the UV analysis. The UV analysis, in the UV analysis, we found that the multifunctional nanofibers shows both the peaks of the silver as well as that of the gold, because they are not alloy, because they are not mixing. Since they are not mixing, they are showing their different peaks, and since both are of the same nature, so they are not masking each other's effect, each others. So by this, we confirm that we have the silver as well as the gold in our system without disturbing the morphology of the core of the functionalized core. So this was the conclusion of my this research, that nano objects of the core shell morphology from polystyrene block P4VP were isolated by self-assembly approach using selective solvent. The shell of the nano objects were functionalized with the metal and the metal oxide functionalities. Core was functionalized with the silver nanoparticles. Finally, multifunctional nanofibers were fabricated with different functionality in both core as well as in the shell. And this was the future outlook which I would like to extend, that core and shell could be functionalized by other targeted functionalities. It could be used for fabricating the nanowires by thermal treatment, biometallic nanowire, aspect ratio tuning could be done. And such interesting study is required for understanding the packing arrangement of the nanoparticle inside the cylinders. So I will acknowledge all my research institutes for this research. And finally, I would like to thank you and welcome you for the questioning session.
Thank you, Dr. Sunita. Now the session is open for one or two quick questions. Any question from audience? Dr. Sunita,
Yes, sir.
is grafting approach for a preparation of nano objects are better compared to block copolymer?
Sir, I found it better, sir. So grafting is a bit tedious, sir. It's lengthier process.
Okay, right. And have you tried for tri-block copolymer?
The tri-block is in our mind. I mean, the future steps, future research will be on the tri-block.
Okay. Thank you, Dr. Sunita. Thank you very much. Now you can close your presentation.
Sir.
Now I handle my mic, the organizer.
Thank you, Dr. Joshi, for chairing the session, and I'm very thankful to all speakers who presented the work. So I think after 110, at 110, we have assembled for paper presentation. So that time, after I think after 30 minutes, no, 25 minutes, after 25 minutes. So exactly at 110, we have assembled for paper presentation. So I'm requested to all participants, please join before 110. Thank you, all of you.
Maybe upon please allow it to be how much 25 minutes. Okay, what is the temperature outside? Need to add distilled water. No need to add distilled water. Sorry, sir. What's the temperature? I couldn't. Put out the flame. Let us cool down. After 10 minutes, you remove this. This is already hot. If you put it into water, automatically it will. Get water. It is very hot.
Excuse me, sir. Shall we start or we have to wait for 4 minutes more?
Yes, Mauna.
Sir, can we start or we should wait for 5 minutes more? Yes, sir.
5 minutes more. Basically, Thakur sir will be joining with, I think, after 5 minutes.
Okay, sir.
Okay?
Yes, sir. Okay, sir.
भावना
Yes, sir.
स्टार्ट करो सब ज्वाइन कर रहे हैं आप स्टार्ट करिए
Yes, sir. So once again, I welcome you all on behalf of organizing committee. So I request Joshi sir, please proceed, chair the session. Thank you, sir.
Thank you very much. Okay, I think that today oral presentation start with number 13, Damini, right?
Yes, sir.
Okay. Okay, now before starting her oral presentation, I like to say something about the oral presentation. The time allotted for oral presentation is around 8 minutes and 2 minutes for questioning and answering. All the participants, I like to advise you that your work is monitored by jury members and the presentation evaluation depends on the novelty of work, your analytical skills or data, clarity of the work, and how you are able to answer questions. So if the first one, Damini, is available. Damini, are you available?
No, sir, she is not there.
Okay, then I will shift it to Anju Jha. Anju Jha, are you available?
She is also not there.
Okay, then we shifted to third one, Dr. Sandhya Dixit. Is she available, Dr. Sandhya?
No. Yes.
Okay, Dr. Sandhya, are you available?
No, sir, she is not there.
Okay, then next is Aditi.
Should be there.
If Aditi is not present, then
If I'm audible, shall I say something?
Yes, sure.
Sir, I am Dr. Sarabjot Kaur. Actually, in my your brochure, my date was mentioned. It is 21/12/21. So I am supposed to present today, right?
Yes, you are at the last number.
Last
I have
one.
shifted you
Okay.
because of there is some we have today
28, right?
Yeah, sure.
Yes.
Sure.
Okay, thank you.
No issue. You are there on 28. Okay, then who is available? Archana Sahu. Swetha.
Yes, sir. Good afternoon.
Okay, Dr. Swetha is there. Okay, Dr. Swetha, you start your presentation. You have 8 minutes.
Okay, sir. A very good afternoon, each and everyone. First, I will share the slide. Slides are visible, sir?
Yes, visible.
Ma'am, Bhavana, ma'am, you are in mute.
Your voice is mute. You are not audible. Kindly unmute.
Now it is okay, sir?
Yes.
Shall I start?
Yes, you start.
Yeah. Sir, very good afternoon, each and everyone. And before starting my presentation, I would like to say thanks to all the committee members giving me this opportunity to present my work here. So myself, Shweta, I completed my PhD with Dr. S.P. Singh sir from CSR IACT. After that, I done postdoc with Dr. Ashish sir at IIT Kanpur. Right now, I'm working as a senior project associate with the Dr. S.P. Singh in the CSR IACT Institute. So today my talk is molecular engine of cost-effective and efficient light harvester for photonic applications. So before starting this, I want to say that my outline of the presentation, this outline presentation. First, I'm going to talk about the introduction of solar cell, why it came into the picture, what is the generations of solar cells. Among them, I have chosen the perovskite solar cell. Why I have chosen perovskite solar cells? What is the benefits of that one, and how it be the device structure, and how many perovskite solar cells available in the literature, and followed by my research work. So coming to the introduction, So according to the sustainable development rules, 7th one is the affordable energy and clean energy we have to address to make the fancy life of the human for the society. So to fulfill this development rule, we have chosen the solar cell, both two type of energy solar cell. One is non-renewable and renewable. Coming to non-renewable, as all you know that nuclear, oil, coal, but coming to that due to the depletion of the fossil fuels and day by day we are facing problem with the petrol, diesel. It is going like anything. So due to that, after some days, that non-renewable energy are not going to use the properly. So in that, to address this one, renewable energy came into the pictures, which includes the solar energy, wind energy, biomass energy, and hydro energy. So among them, I have chosen the solar energy. Why? Because the solar cell is available plenty on the earth, and it is eco-friendliness, and it is clean and green energy. So coming to the other energy sources, solar cells, we don't have pay any money to that one. So that I have chosen the solar energy for my research work. And coming to the solar cells, it divided into 3 generation solar cells. First generation solar consisting the silicon solar cell, which are commercially available nowadays. And but coming to this, it is showing the 24% efficiency, but each and every person to coming to the common people, they are not affordable to buy the solar panels. Why? Because the cost effectiveness. To decrease the cost effectiveness, people move towards the second solar cells, which consist the thin film solar cells. Here the cadmium, gallium and selenium one. But coming to compared to the first solar cell, it is giving the less cost only, but efficiency is not reaching up to the first solar cells. It is showing only 18% efficiency. To address the both cost effectiveness and affordableness, and to make the each and every person usable, people move towards the third generation solar cells, which includes dye-sensor solar cells, organic voltaics, and perovskite solar cells. So we are working on the third generation solar cells. Among them, today I am going to present the work regarding to perovskite solar cells. So these are the basic device structure of the perovskite solar cells. First, we have to take the fluorine doped tin oxide solar cell. After that, we have to put the titanium. After that, light harvester. After that, whole transform material. And after that, the cathode layer we have to coat layer by layer. So why I have chosen perovskite solar cell in the short span time period, because it started around 2012 only, but till now it reached 25% efficiency in the only decade time. So that's why perovskite cells booming nowadays. And this is the basic structure of the perovskite solar cell, that is formed as ABX3. A consists the cation, B is the anion, and C is the B is the anion, X is the halogens, that are chloride, bromide, iodide. And most probably the perovskites are available in the tetragonal structure and cubic structure. Coming to the mechanism principle, when light falls on the light harvester, that is a perovskite, it will form the exit ion. The exit ion is nothing but a combination of electron and hole, and the electron moves towards the corresponding electrode, and hole moves towards the gold electrode. To complete the cell cycle, it will give the electricity or as the output. So apart from these devices, today I'm talking about the perovskite, which is a light harvesting material. And these are the made up of in our lab the perovskite solar cells. And if you want to make the perovskite, means light harvester, you have to, it has to fulfill some fulfillments. Why? What is that? If you want to prepare the light harvest material, you have the capability to harvest the solar spectrum. That is a one criteria. And moreover, to get the good efficiency, it have the tunable energy levels. That is a one more criteria. And third one is that it have the good hole mobility and electron mobility towards the corresponding electrodes to fulfill the cycle and give the electricity as an output. So coming to my work, so based on this perovskite, as I told that the perovskite have the ABX3 form. So in the first work, I played with the A. You can play with A, B, or X. So in what we have done, even perovskite showing the efficiency 25.5%, but it's not going for the commercialization because the toxicity of the perovskite solar cells. So in the perovskite, it have the lead content. So due to the toxicity, we are unable to go for the commercialization. So one thing we have to do, we have to reduce the toxicity, otherwise we have to remove the toxicity. So people tried to remove the lead and replace with the tin, but the solar cells are not stable. But in one scope, what we have to reduce the toxicity of the lead. So how we are going to reduce the toxicity means we have doping some impurities to the B phase, and we are reducing the toxicity, and we are making the perovskites for the commercialization purpose. So in this work, what we have done, we have prepared the cesium inorganic perovskite solar cells doped with the iron molecules. Coming to the synthesis, we have taken the lead chloride and we have used some capping agents. Why? Because to make the stability, to make the geometry properly, we have used the capping agent like oleic acid, octadis, and olalamine. And we have stirred it for 30 minutes at 120 degrees. So after the 30 minutes, we have added the cesium oolate in the presence of, when the temperature reached to 200 degrees. So this is a cesium lead perovskite, which is in color of blue, but when we are doping with the iron one, it is giving the pink color. That means the iron dope perovskite show the dual emission property, which is favorable to make the OLD solar cells. So these are pictorial one. One thing is it have two beneficiary. One is that it is playing the dual color emission, and it is increasing quantum Hill effect. Photoluminescence quantum effect. When this undoped one is showing 1.8% efficiency, when we dope with the iron, it is increased up to 4.2 lead hydroxide, and it is confirmed by the XRD analysis. And it is showing the geometry as the cubic nature, which is available in the literature. We compared with the cubic structure of the perovskite. It is exactly matching with the cubic structure. And when we are doped with iron, the broadening and shifting, little bit shifting is happening in the XRD. It is confirmed the iron metal is present in the cesium lead perovskites. To more confirmation, we have done the absorption studies, emission studies, and lifetime studies. So this coming to this is a UV absorption spectra. When you take in the undoped material, is showing around 414 nanometers only lambda maximum. But when doped with the iron, it is blue shifted towards 400 nanometer. And this is a one proof from the UV. When you coming to the emission studies, it showed the emission around 419, and apart from that, it's showing one more recognizable peak, which is indicates that our doped one is changing from another color to another color. This is a means emission proof for that one. By blue is changing to the pink color. And coming to the means to know the lifetime of the our perovskite solar cells in the photon form, we have conducted the lifetime studies, and the undoped one is staying the photons taking time 44 nanoseconds to reach the laser light, but when the doped one, it's taking less time compared to the undoped one. So
Dr. you have 2 minutes.
Okay, sir.
8 minutes already.
This to go in depth to conclude, we have done the morphology studies also. And coming to SAD pattern, the iron presence we came to know from the Irtst. And for the more confirmation, we done TEM images also. From that, we found that our particle is in the 12 nanometers. And to continue this work, we have went to the 2D perovskites. The 2D perovskite is nothing but the spacer. One spacer cation is present between the two shells. So in that, we have prepared some 2D perovskite by using the different alkyl benzylamines. So these are synthetic processes of the benzylamine. What we have proceeded for the 3D perovskite, we have done with the same. And these are our pictorial structure of the 2D perovskite. This pink color is what we have used the cations, which we have replaced. And these also we have confirmed with the absorption studies, emission studies, XRD studies, and lifetime studies also. To go in depth into morphology studies we have done. So coming to this P1, it is showing the microdiscs always a nanorods also. That's why the XRD is somewhat it's a combination of two. So it is showing the two morphology. But when coming to the methoxy substituted alkyl amine, it is showing only microdiscs. So it is confirmed by that clearly XRD spectrum. And coming to the conclusion, so to make the perovskite solar cell affordable and commercialization, we have prepared the 3D and perovskite solar cells. And in 2D perovskite, sir, in 3D we have played with the B space, B anion, and in 2D space we have played with the A cation. So these both cells we have when we prepare the 3D perovskite, we applied for the OLD application. When we done the 2D perovskite cells, we are going for the solar cell application, various photonic application. The device fabrication is under progress. So this type of new work will give enthusiasm to the future researchers to work on the perovskite solar cells. So this acknowledgement, I want to thanks my director, which is a recently appointed secretary for DST, and I always thankful to my supporter, motivator, my supervisor, Dr. S.P. Singh sir, and my postdoc supervisor, Ashish sir, and my heartily thanks to the committee members who giving me this opportunity, especially Ajay Singh sir and Bhavana ma'am. Thank you for your attention.
Jury members.
Okay, Sweta.
Sure.
Very nice presentation.
Thank you.
Sweta, I have some small question.
Please, sir.
1 minute. What is quantum yield?
Sir, quantum yield, sir, we have we have one formula, sir. That area under the curve we taken from the emission spectrum, area under curve of the sample, area under curve of the standard one, into that quantum yield of the reference.
Okay.
That PLQY is equal to A of the sample, A of the reference into quantum yield of the sample, and what solvent you are going to use, that is neat of the solvent by neat of the sample.
Any instruments we can direct measure it?
Sir, from this only, sir, just coming to the emission study, so this is somewhat visible for you. So I will make the UV absorption, sir, which is we are going to make the OD below 0.1. So I will make the OD of the our compound. I will make the UV, and that lambda max should be below the 0.1. And then same sample I have done with the I will carry out the emission studies, and we will find out the emission spectra. So that emission spectra, what we are observing, that area under the curve, I will take it from the origin, and the area under the curve I will substitute in the formula. Then I will get the quantum yields.
What is actual problem in this sample? Basically, there is stability is one of the biggest issue in this sample. And there any problem with this perovskite solar cell? That material was discovered for the solar cell.
Yes,
but
sir,
nowadays, people are not using for solar cell. People are moved for some LED purpose and many more things.
The solar cells, if you want to make a first, I'm sorry. Okay.
Okay. Continue.
Sir, solar cells means if you want to go for the solar cell application, we have to make the solar panels, which is useful for the society. So coming to our perovskite solar cells, till now we find out the two drawbacks. What is that? So in perovskite cell, we are using the lead one, sir. So lead anion, which is toxic to the society. And coming to stability, sir, without glow box, we cannot prepare the perovskite solar cells. So that's why we are preparing, we are find out the synthesis processes which can stable, which can we prepare in the RT. So this 2D perovskite, all I have synthesized in the presence of RT only, sir. It's stable up to 30 days only, sir. So I am changing the synthesis procedure and doping with another material, which will give the more stability. I want to avoid the glow box, all these things, and I want to make the stable perovskite. So that's why we are wearing the different synthesis. Like till now, I adopted the ligand assisted laparoscopy and spray type and crystal. All these synthesis we are optimizing, sir.
Okay, thank you, Sweta. Basically, we are very late. So next, please, Joshi.
Yes, sir.
Yeah, please call.
Thanks, Dr. Sweta. Now I call on DT.
Sir.
Yeah, sir.
Hello.
Santosh Thakur, sir, wants to.
Yeah. So, it's nice presentation, convincing presentation. Do you have? Can you give any example of dye sensitized solar cell?
Yes, sir. Actually, my total paste work and dye solar cells, I worked on the metal complexes, sir. I have prepared ruthenium complexes, sir, for dye sensitized solar cells. Actually, in the dice in solar cells, the standard dice are there, red and black dice. Black dice nothing but N719. So it have ruthenium metal ligated by terpidin ligand and terpidin ancillary ligand and anchoring ligand, sir. So I played with the ancillary ligand. I changed the different ancillary ligand with the anchoring group, sir. And I have prepared NCS free metal complexes and NCS complexes. But coming to that, when I have 3 NCS, it is giving less efficiency. But when I replace with a completely 3 NCS with another terpidin ligand, yeah, that time also I'm getting less efficiency. What we thought, NCS is necessary to maintain the efficiency. So I prepared the one complex, only one NCS considered, bipedine based ligand as ancillary ligand and terpidin as a anchoring ligand. So in that I got 8.2% efficiency.
Any other metal other than this ruthenium?
Ruthenium metal free I have done, sir. Phenothiazine based, phenoxyzine based, and which is anchored with the cyanistic acid one.
Okay, okay, thank you.
Thank you, sir.
Thank you, Dr. Sweta. Now stop your sharing. Now I invite Aditi. Aditi, are you available with your slides?
Yes, sir.
Okay, start your presentation.
Yes, sir.
Dr. Sweta, can you stop
Okay,
your
sir.
sharing?
I'm stopping.
Sir, am I audible?
Yes.
Yes, sir. Good afternoon to all of you. I am Aditi Panchari, Research Scholar of Government VYT PG Autonomous College, Durg. My topic is synthesis and characterization of lead-free perovskite material. These are the contents. Now, introduction. Perovskite is a calcium titanium oxide mineral with chemical formula calcium titanium oxide. The mineral was discovered in a Ural mountain of Russia by Gustav Rose in 1839, and it is named by Russian mineralogist Lev Pavlovsky. The crystal structure having CaTiO3 like namely ABX3 termed as perovskite. In a perovskite structure, ABX3 type of anion where A type A is large size cations, which is present in a corner of the crystal structure. B is a small size cation, which is present in a center of the crystal structure, and X is present in a center of the face. This figure show how the solar energy is converted into the electric energy by the photovoltaics. Now, classification of solar cell. Solar cell is categorized on the 3 generations. In the first generation, water-based silicon. In the second generation, thin film technology. And in the third generation, new emerging technology includes nanocrystal-based solar cell, polymer-based solar cell, dye-sensitized solar cell, perovskite-based solar cell. Now, organic inorganic hybrid perovskite. First 3-dimensional organic inorganic hybrid perovskite is replacement of cesium in cesium-lead halide with methyl ammonium cations by Dieter Weber in 1978. Methyl ammonium lead iodide is most common material for making high efficiency perovskite solar cells. Methyl ammonium is large size and spherical shape, so it causes distortion in network and drives several phases. The main purpose of this work is replace lead with cadmium for the synthesis of new material is hybrid cadmium halide perovskite, which is methyl ammonium cadmium chloride. Now, the preparation of precursors. I have taken methylamine solutions with hydrochloric acid. This was kept in ice cold conditions. After shaking and evaporations, precursor crystal were obtained. These images show the precursors, and it is poured in a watch glass. Now, the preparation of perovskite materials. Above precursor material and add cadmium chloride. It is dissolved in DMF solvent. After the stirring, material was obtained. This image show methyl ammonium cadmium chloride. This is the device structure of the perovskite solar cells. Perovskite solar cells is it includes 3 different layers. One is light absorber layer, which is used for the converting incident photon to electron and hole. And the carrier collector, it is capturing the carrier electron and hole. And the metal contact layer, it transferring the carrier to the circuit. I will discuss FTIR and UV spectroscopy techniques. In a UV spectroscopy techniques, it is used for the, it is direct and simple method to study the absorption behavior of materials. I have observed the UV range is 230 to 300 nanometer. Absorption peak is observed. After the literature survey, after the many literature survey, the this absorption band show band to band transitions. It is valence band of chlorine or a 3p orbital to the conduction band of cadmium 5s orbitals. After the behavior, after this observation, calcium methyl ammonium cadmium chloride behave as a semiconductor materials. And this figure number 5 show FTIR spectra. FTIR spectra, it measures the vibrational mode, and it is more precisely the vibrational variations of molecules when they are irradiated by an electromagnetic wave of adequate frequency. Methyl ammonium cadmium chloride having 3 vibrational frequency. One is CN frequency, and other is CH, and another is NH frequency. I have compared this methyl ammonium lead chloride, and here in the graph, the 3700 centimeter inverse frequency range show the symmetric stretching of NH3 plus, and the 2800 centimeter inverse show the methyl radical frequency of methyl radicals, and in between the range of 2000 to 2900 centimeter inverse couple combination of fundamental modes, and rocking stretching of methyl ammonium ion is 930 centimeter inverse. Now, acknowledgement. Our college group. These are the references. Thank you.
Thank you, Doctor. Thank you, Aditi.
Yes, sir.
Now, do you have questions?
Yes, sir.
Thakur sir.
Yes, I have one fundamental question.
Ji, sir.
Yes, it is related to undergraduate class, not at research level.
Ji. Yes, sir.
So, 1 centimeter inverse, if you go for energy conversion,
Ji.
1 centimeter inverse is equal to how much kilocalorie per mole or kilocalorie per joule?
Sir, 2 calorie. Sorry, sir. Actually, energy value is 2 calories, sir. I am not actually.
So you are saying
Sorry,
1 centimeter inverse is equal to 2 kilocalorie per mole, 2
No, sir.
kilocalorie per mole.
नहीं सर, सॉरी सर, एनर्जी का वैल्यू बता रहे थे सर, 2 किलो कैलोरी सर.
No, I am asking. Yes, this is the when we are going for advanced level presentation, na.
जी, yes sir.
We should have also idea about the some basic question.
Yeah, sure, sir. I will discuss. मतलब I will study about this, sir. Sorry, sir.
In IR spectra, why we show the wave number in centimeter inverse? Why not like in?
Sir, because sir, it is a reciprocal of wavelength, sir. Wave number is the reciprocal of wavelength.
Hello, can you hear me? From my side, it is okay, sir.
Yeah, it's okay, sir. Your voice is clear.
Yes, thank you.
Thank you, sir.
Okay, then next.
Okay.
Okay.
Aditi, now you stop your sharing. Now I will invite Priya Sharma. Priya Sharma, are you available?
Yes, sir.
Okay, go ahead.
Good morning, sir.
Good morning. Good afternoon.
Sorry, sir. Good afternoon. Okay. Sir, is the screen is visible?
Not yet. Okay, now visible.
Okay. Good morning, respected professors and research scholar. I am Priya Sharma, and my presentation topic is synthesis of cerium oxide nanoparticle by precipitation method. These are the content. Before starting the introduction of cerium oxide nanoparticle, I would like to explain what is nanoparticle. Nanoparticle are the particle ranging from 1 to 100 nanometer size. They are basically present in 0 dimension, 1 dimension, 2 dimension as it is. Now I would like to start introduction of cerium oxide nanoparticle. Ceria is a lanthanide rare earth metal. Its atomic number is 58. It is a white silvery metal. It is very soft. It can be easily cut with knife also. When it oxidizes, it tarnishes. Cerium oxide is calcinated in cerium oxalate and it forms cerium oxide. Cerium oxide is there are various methods for preparation of cerium oxide nanoparticle like electrochemistry, deposition, templates, photo-induced conversion, biological synthesis. But out of these techniques, chemical precipitation is one of the most exclusive technique for synthesis of cerium oxide nanoparticle. Because of its very huge properties, that's why cerium oxide can next. Cerium oxide has a very strong antioxidant property also because it can oxidize the contaminated water. So there are the various type of organic dyes like alzarin, Congo red. These are the various type of dye which can create a harmful effect to human being, animals. That's why though these cerium oxide can play a very great role for catalytic activity. So this cerium oxide nanoparticle is used as a catalyst which help to degrade the dye. Next. This is a prepared cerium oxide nanoparticle experimental method. All the chemical reagents used in experiment were obtained from commercial sources as guaranteed grade. 0.1 molar CTAB solution is mixed with distilled water. It is stir under homogenized condition, then add ammonia solution until it homogeneous solution was obtained. Then after we adding 10 ml ammonia, then after we adding saric chloride, we filtered the solution. Then we distilled, the filtered material was washed with distilled water for removing the surfactant. Then we dried and finally we obtained the cerium oxide nanoparticle. It is basically look like a pale yellow color. And this process was repeated again by changing surfactant. Characterization of cerium oxide nanoparticle. This Fourier transform infrared spectroscopy, FTIR spectroscopy is basically used to identify the functional group. Scanning electron microscope is basically used to identify the morphology. transmission electron microscope is it is basically a light based imaging technique, and UV visible spectroscopy is used to measure the size concentration of the particle. The UV visible range is basically from 200 to 800 nanometer. Fenton's process and dye degradation. Fenton's process, Fenton's reagent is a reagent which is a mixture of hydrogen peroxide and iron. Basically, it is used for dye degradation. Dye degradation. Sweet. Dye degradation. After synthesizing cerium oxide nanoparticle by using these three different surfactants, SDH, cetyl trimethyl ammonium bromide, cetyl pyridium chloride, these surfactants control the growth of prepared nanoparticle.
Okay, slide is not moving.
Yes, sir. Sorry, sir. I try.
You maybe zoom out.
Yes. Sir,
Zoom.
sorry, sir. Slide is not moving.
No
I
worry,
try.
no worry, no worry. Just zoom out.
Zoom out.
Yeah. Now try individual slides from left hand side panel, display panel, preview
Okay.
panel. You click on preview panel. Yes.
Thank you, sir. Result and discussion.
You directly move to the conclusion part because already 8 minutes were passed.
Okay, sorry, sir.
No, no, up arrow, up arrow. Use up arrow. Down arrow,
Sorry.
down arrow. Slide number 19. Click on slide number 19.
Slide number 9.
Yeah. This is down, no, down, not up, down. Go down, not up. Move your cursor down. Scroll down.
Okay.
Down, cursor down. Drag it down, or down. Down. Now on the left hand side, click the slide. But stop. Click on 19 number slides.
19. Okay, sir.
Click. Okay.
Sir, nanoparticle of cerium oxide have been prepared by using ammonium ceric nitrate as a precursor. The morphology is examined by SEM TEM UV visible. Sir, can I explain the uses?
No, actually, you are out of time.
Yes, sir. Sorry, sir.
No
Actually,
issue. No worries at all. Now I hand over to jury members.
Thakur sir.
Yes.
Yeah.
Do you have any idea to prepare this oxide, this cerium oxide by top-down approach?
what, sir?
Can we prepare the material you have prepared by precipitation method by top-down approach?
No, sir. I can prepare by precipitation method.
No, have you come across any literature which mention that it can also be prepared by top-down approach?
No, sir, I have no idea.
You have no idea. Do you know any nanomaterial which is having the tetrahedral geometry?
Tetrahedral. Zinc oxide nanoparticle.
In which research paper it is given that zinc oxide is having oxide nanoparticle is having tetrahedral geometry?
Zinc oxide is hexagonal. Priya.
What, sir? Yes, sir.
Have you ever heard about the 3D nanoparticle?
Yes, sir. Graphene.
Graphene. It is
Yes, sir.
particle or what? Graphene is nanoparticle.
No, sir. Graphene is come under three-dimensional nanoparticle.
Okay. What about nano rods, nano sheets, and other dimension or other size and shape of the nanoparticle? Nanomaterials?
Sir, basically, sir, it is a zero. Nanoparticles are basically of 0 dimension, 1 dimension, 2 dimension. Sir, just like fullerene. C60 fullerene is an example of 0 dimension, and the various carbon nanotubules is of 1 dimension, and graphene is under 3 dimension, and graphite under 4 0 1 2 3 dimension. Sorry, sir.
Okay, no problem. Good presentation. Jai Singh sir, if you have any question.
Yeah, what is the role of CTAB?
Sir, CTAB is a cationic surfactant.
Okay.
Yes, sir. CTAB is a cationic surfactant. Then this surfactant is actually, sir, this surfactant has
That work as a reducing agent or what?
What, sir?
That works as a reducing agent?
No, sir. It is a oxidizing reagent. It is a cationic reagent, sir. It is basically
Work as a catalyst.
What, sir?
As a catalyst.
No, sir. It is a surfactant. CTAB is a surfactant.
Okay.
What
is actual role of this surfactants?
Sir, these surfactant have these surfactant is used against bacterial and fungi, sir. Matlab this cetyl methyl ammonium bromide is a cationic surfactant. It show effective antiseptic agent against bacteria and fungi.
कहाँ से कहाँ पहुंचा दिया आपने? चलो ठीक है. It's okay.
अच्छा, last question. What happens if we elongate the hydrocarbon chain in cetyl part? If we take longer hydrocarbon, then is it affect the size of your nanoparticle or it will be unaffected?
Sir, hydroxyl particle.
No. Hydrocarbon part. Cetyl is the hydrocarbon part, na?
Yes, sir.
So if we elongate, suppose in place of C17, we take C21 or C31. So what will be effect on the size of your nanoparticle?
Sir, the size will be larger.
So that is what sir is asking. What is the role of CTAB?
Okay, sorry, sir.
Anyway,
I understand.
Anyway, all the best. Okay.
Thank you, sir.
Okay, Priya. Now stop your sharing.
Okay, sir.
Is Aisha Hasmi is available?
Yes, sir.
Okay. You start your presentation.
Okay, sir.
Priya, stop your sharing.
Yes, sir. I'll try.
My presentation is visible, sir.
Yes, visible.
Okay. Good afternoon to all of you. Myself Aisha Hashmi, and today's my presentation topic is green synthesis of graphene oxide by using Phyllanthus amblica and its photocatalytic activity on cationic dyes. These are the contents. Now, introduction. What is nanomaterial? Nano means dwarf. It comes with a Greek word. Nanoparticle are particles that have at least one dimension less than 100 nm. Mini is mighty, a perfect phrase to describe a nanoparticle. Now, what is graphene? It is a miracle material. It is a sp2 hybridized carbon atom arranged in a honeycomb lattice. It is a transparent, faster, stronger, one atom thick. Graphene can be synthesized with a graphite to create the thinnest, strongest, and most conductive material known today. It is 6 times lighter, extremely thin and transparent and bendable. These are the structure of graphene oxide. Graphene oxide is generally made up of 3 functional groups like epoxy, carboxylic, and hydroxyl group. Future hope from graphene oxide. There are so many future of application of graphene oxide in the field of antibacterial activity, tissue engineering, control release, cancer therapy, parasitology, and imaging. As we already know, the whole world facing a global pandemic due to the coronavirus 2. There is graphene and its derivative are our new hope in this pandemic time. There are so many products are available in market like graphene mask, graphene PPEs, and biosensor, etc. Objective of my present work is synthesis of graphene oxide by green root. Characterization was done by XRD, SEM, HRTM, and FTIR, and application in photocatalytic activity. Now, why I'm synthesizing graphene oxide? Because it is a lightweight, very thinnest material, large surface area, high electrical conductivity, unbreakable to some extent, and very flexible. Method of preparation. There are several methods available for the synthesis of graphene oxide. Generally, chemical methods are available, but during the synthesis process, there are so many harmful and toxic gases are emitted. So here I choose the green way to synthesize graphene oxide. In this experiment, I use amla leaf as a carbonaceous source, and these leaves are dried in the sunlight and chopped and converted into the powder form, then put into the crucible and mixed with the ferrocene at 350 degrees centigrade under muffled atmosphere. Then black solid residues was obtained, called graphene oxide. There are so many characterization techniques are available for the for knowing the sample is prepared or not, like XRD, Fourier transform, infrared spectroscopy, scanning electron microscopy, high resolution transmission electronscopy, and UV visible spectroscopy. Result and discussion. X-ray diffraction analysis. XRD is generally useful for the determination of the crystalline size of the particle. Here, figure 1 shows the XRD images of graphite and graphene oxide. For graphite, XRD image of graphite, diffraction peak is obtained around 26.3 corresponding to the 002 plane, and for graphene oxide, diffraction peak is obtained at 12.2 corresponding to the 001 plane. For graphene, it shifted into the lower angle due to the complete oxidation of graphite into the graphene oxide. Here's various parameter of XRD. The size, particle size is obtained for graphite is 5.48 nm, and for graphene oxide, size of the particle is obtained at 2.84 nanometer. D spacing of for graphite is 3.37 nanometer, and for graphene oxide, D spacing is obtained at 9.22 nm. Here, D spacing of graphene oxide is just double as compared to graphite because of the intercalation of the water molecule. Fourier transform infrared spectroscopy analysis. FTIR is generally useful for the determination of the functional groups of the compound. Here, figure 2 shows the FTIR images of graphite and graphene oxide. Here, 3449 and 3419 centimeter inverse peak is due to the hydroxyl group. 2925 and 2860 centimeter inverse is due to the carbonyl group. 1616 is due to the NH bending vibration of secondary amine. 1519 and 1445 is due to the arene group. 1210 and 1097 is due to the ester group. 1038 due to the amine group. 0 centimeter inverse peak is attributed due to the AlFeOH bending vibration of the molecule. Peak at 756 is due to the carbon hydrogen out of the plane bending vibration of the trans and E alkene. And peak at 517 and 516 centimeter inverse is the bending vibration of the molecule. Scanning electron microscopy. SEM is generally useful for the determination of the morphology of the compound. Here figure 3 shows the SEM images of synthesized graphene oxide. In these images, it is clearly look like a folded sheet-like structure. High resolution transmission electron microscopy. Here figure 4 shows HR10 in shade pattern of the graphene oxide. It is HR10 of graphene oxide is clearly look like a agglomeration of the particle, and shade pattern shows hexagonal system and polycrystalline in nature. Figure 5 shows the size distribution curve of the graphene oxide. Photocatalytic activity. The synthesized graphene oxide was used as a photocatalyst for the degradation of two cationic dyes, namely malachite green and methyl violet. When we increased the exposure time, rate of degradation was also increased. And this figure 7 shows the photodegradation and kinetic study of the methyl violet. Here I study the kinetic study of this, and this is follow a pseudo first order kinetic reaction. This is the conclusion. In this work, I have synthesized graphene oxide by Phyllanthus amblica leaf using muffle atmosphere. It is a single step method, and ferrocene was used as an oxidizing agent. Here we introduce a simple green, cost effective and environmentally friendly route. Other silent feature of this green technology is the most operated at a mild condition, room temperature and atmospheric pressure, making it affordable and cost effective. Here malachite green and methyl violet cationic dyes are used for the degradation process. The photocatalytic activities of the synthesized graphene oxide were estimated for the degradation of these two cationic dyes under replication of the solar light. Synthesized graphene oxide was analyzed by different chemical and physical methods like XRD, FSM, EDS, FTIR, and HRTM. And the photocatalytic degradation of graphene oxide was 94% for brilliant green, malachite green, and 120-minute, and 99% for methyl violet in 120 minutes. These are my references. These are the list of publications. Acknowledgement. My sincere thanks to the government PYTPG Autonomous College and Siddhachalam Laboratory, Raipur, to give me the opportunity to present my work here. Thanks to SEF Cochin Chennai for providing sample analysis facilities. My sincere thanks to my supervisor, Dr. A.K. Singh, Principal Dr. R.N. Singh, Government PYTPG Autonomous College, Durg. Thanks to Head of Department, Dr. Anupama Asthana. I would like to thanks all my professor and lab mates to Department of Chemistry for their constant support. Thank you.
Thank you, Aisha. Over to jury members.
Thakur sir.
Yes, it was a good presentation.
Thank you, sir.
So, which type of hybridization you explored in graphene oxide?
Sorry, sir, please pardon.
You said it is sp2 or sp3 type of hybridization between carbon-carbon. Which type of hybridization is there in the structure?
Sir, it is a hexagonal structure of graphene. So it,
you said somewhere, I forgot the slide number, that is sp2 hybridized state like that. Is it?
Yes, sir.
sp2 or sp3?
sp2, sir.
How do you ensure it is sp2, not sp3?
Sir, sorry, sir.
Okay, no problem. And do you know any example of graphene oxide working as a electrocatalyst?
Sir, electrocatalysis.
You have shown in photocatalysis.
Yes, sir.
But what about, have you gone any literature where it
I
mentioned
think
that?
there are so many literature available for electrocatalysis, but I don't study this. Only for photocatalysis.
Okay, you have done only for photocatalytic study.
Yes, sir.
And so whether this graphene oxide works as a support or as a catalyst? Catalyst
Sir, as
support
a
or
photocatalyst.
okay, as a catalyst, not as a support.
Yes, sir.
Okay, yes, sir.
Magic. Okay, sir. Please go ahead.
Okay, sorry. Please.
No, sir. It is over now. No problem.
Okay, sir. What is the difference between graphene oxide and graphene?
Sir, graphene oxide is a two-dimensional carbon material. Graphene is a multi-layer system, sir, and graphene oxide is a few-layer flakes and a monolayer flake system.
No. तो ग्रेफीन ऑक्साइड और ग्रेफीन ऑक्साइड से क्या ग्रेफीन बना सकते हैं?
यस सर, उसको रिड्यूस करके हम ग्रेफीन में उसको फिर से कन्वर्ट कर सकते हैं यूजिंग रिड्यूसिंग एजेंट.
Okay. Any which type of reducing agents?
Sir, I have used green reducing agent like capsicum annum and hydrogen hydrate is a chemical which we can use in the reduce for graphene oxide.
You have written green synthesis. What is green? Here.
Yes, sir.
In your, I think in your process, what is the green methods? What is green synthesis?
So in green synthesis, my method is a single step method, and when we use chemical method, there is
you are not using any I think biological.
No, sir, I was used oxidizing agent.
Okay.
And amla leaf used as a carbonaceous source.
Okay. ठीक है sir. Next.
Thank you. Okay. Thank you, jury members. Thank you. I say it was very nice presentation.
Thank you so much, sir.
Okay, now you stop your sharing.
Yes, sir.
Now we'll call upon Siddhant Kumar. Siddhant Kumar, are you available?
Yeah.
Okay, you start your presentation.
Can you see?
No, sharing is under process, but not seen.
Okay, I will try. Yeah, is it available?
Visible.
Okay, my name is Kumar Siddhant and I am a doctoral student in Irtst University, Japan. Today I am going to present my recent research work and the topic is multicolor emission from gold 1 NSE coordination polymer. So organic luminescent molecules play a very important role in materials and life sciences. So it has various practical applications like it is used in OLED sensors, etc. So the conventional organic luminescent molecules at low concentration shows emissive phase, but at high concentration it shows non-emissive phase due to collisional interaction between them. So here we can conclude that fluorescence decreases with the increasing solution concentration. So next, to overcome the problems of conventional organic luminescent molecules, ACQ like aggregation cost quenching comes into the picture. It shows emissive phase in solution state, but in solid phase, it shows non-emissive due to pi stacking. So aggregation plays a destructive role in light emitting process. So to overcome the problems for ACQ, Tang and co-workers developed a process of AI, which is aggregation induced emission. So it says that when we increase the fraction of bad solvent, the emissive behavior increases, and when rotation and vibration is restricted, then the compound shows emissive phase. Hence, aggregation plays a very constructive role in light emitting process. So the luminescence behavior mainly depends on AU distance, since two AU atoms can form orophilic interaction. So, and the value of orophilic interaction should be less than 3.6 angstrom. Then luminescence can be easily seen. And if there is the distance between the AU is more than 3.6, then luminescence intensity decreases. So luminescence behavior depends upon the AU distances. So we have chosen N-cyclic carbene for designing our material, as NSCs has strong sigma electron donation and weak pi acceptance. Therefore, it possesses more thermal stability, which is also favorable property of luminescent materials. And the less steric crowdedness around nitrogen atom leads to the formation of AU-AU interaction. So here is my present work. So the synthetic procedure of Bi2 poly is stated, and the crystal structure is also mentioned. So basically, we have investigated the solid state study of Bi2 poly, and we got very interesting results. We can see that in crystalline phase, it shows white emission. It shows white emission containing band A, B, C, D, but at light press, it shows yellow emission. And when more pressure is applied, so it turns to pale yellow emission, and upon vapor exposure, it changes to bluish white emission. But when we recrystallize the after vapor phase, so we did not get the original form, that is white color. So now we have changed the crystallization solvent. On crystallization with methanol and DCM, it shows white emission, but when it is crystallized with DMSO and water, it shows green emission. We can see from the graph that band C, this is band C, band C is originated, which is due to crystal induced emission or emission aroused from the aggregated molecules. So we now will discuss the effect of heating on luminescence. Since we can see from the graph that at 5% decomposition, there is the weight loss occurs at 151 degrees centigrade. So we have confirmed, like we try to confirm that whether this is from moisture or from the material. So we heated the compound, and we found that, and we checked the NMR and found that the 151 degrees centigrade, it is the weight loss is due to atmospheric moisture, and the original weight of the 5% decomposition comes at 348 degrees centigrade, which is very high, which denotes that it is very high thermal, which have high thermal stability. So we have checked the luminescence in the crystal state and after heating. So we see that the here band C, we found that the band C is more prominent after heating. So the Bi2 polycrystal after heating changed to bluish white crystal. So we to study about the band C, we have done the AI experiment. So in AI experiment, this is like it is non-emissive. This is 0%. So, but as we increase the fraction of bad solvent, the emissive, we can see the emissive behavior, and the sharp increase in the intensity denotes the that my material is AI active. So this is a CI plot which we have done like to change. And there it shows various color change upon exposure to external stimuli. So this is a summary of my research. Thank you.
Thank you, Kumar Siddhant. It was very nice presentation. Question from jury members.
You mentioned somewhere the bond length between AU and AU 2 point something. Can you see that slide? Yes, this one 2 point. Next one. Next one. Next slide. Next one. Yeah. 2.8 to 3.71 angstrom. Yes. So is it a calculated one or experimental value?
This is calculated and theoretical. This is theoretical value.
How you calculated? Which basis set you have taken?
No. This 2.8 to 3.7 is already like reported in literature only previously. Yeah.
In the literature, they have gone through DFT calculations or something like other type of calculation.
Yeah, means that basically this phenomena was observed by a Chinese research group, Tang. So they have done they have done many they have done DFT calculation to prove the
which basis set and which model they have taken.
This I have not gone through. Sorry for this.
You don't have idea.
Yeah, I don't have idea about this like computational thing.
Okay, so what is difference between chemiluminescence and bioluminescence?
Chemiluminescence, in chemiluminescence, basically the luminescence arise from like any chemical type of substance, but in bioluminescence it is natural.
Okay, which material is famous in bioluminescence?
Bioluminescence.
It is.
Sorry, I don't remember.
And can you give any example of chemiluminescence material?
Chemiluminescence material. Chemiluminescence, like luminophores, which can like TTP, tetraphenylethane is.
Okay, good. Your effort is very nice and your research work is also appreciable. Thank you.
Yeah, thank you.
Okay, sir.
Jai Singh, sir.
Next, sir.
Okay. Sakila Banu, are you available?
No, sir, she is not.
Okay, then shifted to Khushbu Sahu. Khushbu, are you available?
I think, sir, she is also not available.
Okay, then the next one is Yogita. Yogita is available, I think. She is there on.
How many students left, sir? How many scholars? Joshi, sir?
Yeah, around 28 are there, but I think many of them are absent.
No, I mean the presenter. How many left who are going to go for oral presentation?
Around 7.
7 is left.
Around 7. I think Yogita is available. Her name is showing on the contact participant. Yogita, are you available?
Yes, sir.
Yeah, you answer it and you start the presentation fast. Yes, Yogita, start your presentation. Your mic is muted, unmuted. Yogita, your mic is muted, unmuted.
Good afternoon to respected sir and madam. My name is Yogita Sahu. I am research scholar under the supervision of Dr. Rajmani Patel sir and co-supervision of Dr. A.K. Singh sir. My topic is waste material turned into the novel adsorbent in the form of carbon dot composite waste water treatment. These are the contained introduction, synthesis method of carbon dot and their composite, result and characterization and application conclusion. The nanotechnology is the managing matter at a very small scale, 1 to 100 nanometer. The word nanotechnology used in Nanot and UG in 1974. Nanomaterial are those material having the particle size 1 to 100 nanometer. Then nanocomposite, the hybrid material that are produced by the mixing of nanomaterial with matrix, in which at least one material having the dimension between 1 to 100 nanometer. In the nanotechnology, we study two type nanodots. First is the quantum dot, second is the carbon dot. Quantum dot are nano-sized semiconductor having the dimension 2 to 10 nanometer. It is the zero dimensional. The term quantum dot coined in the 1986. They were first synthesized in a glass matrix by Alice Ekimov in 1981 and in collider suspension by Louis Blue in 1983. They were first theorized by Alexander Ifros in 1982. High quantum yield, excellent photostability, higher molar, and it is widely used due to their unique properties in solar cell, photocatalysis, laser biology, and etc. Then second is the carbon dot. Carbon are nano-sized carbon material having the same dimension like quantum dot 2 to 10 nanometer. 2 to 10 nanometer. It is first discovered by Zhu et al. In 2004 during the purification of single-walled carbon nanotubes. This is a new class of fluorescent carbon dot carbon nanomaterial. Carbon dot possesses having excellent different type properties like high stability.
Yogita, your slide is stick on one position.
Yes, sir. Having the extremely miraculous properties like high stability, water solubility, biocompatibility.
Yovita, your slide is not moving. Your slide is not moving. Please check.
Yes, sir. Sorry, sir.
Scroll or zoom in.
The basic difference between the quantum dot and carbon dot only one that they are cytotoxicity.
Again,
and
your slide is not moving. First, you check your slide.
Sir, this is the slide.
Resume slides.
Sir, this is the next slide, sir.
नहीं आइए बेटा next slide.
I think she has to restart. Then that would be okay. I think.
Yes,
she
sir.
has to restart. Yeah.
These are the charts through compare their cytotoxicity.
First close your whole
Yeah,
slide.
moving.
Again, you are
moving.
Now it is okay.
Moving.
Now it is okay. Yeah.
Working.
Yes, sir.
Slide is working.
This is the graphical representation of carbon dot till development 2004 to 2020, where synthesis and application are taking place. And there are many sources for the synthesis of carbon dot. I used carbon dot synthesized from the waste material. These are waste material, maybe biomass and non-biomass. Biomass including plant waste, and second is the animal waste. Non-biomass including polythene waste, paper waste, and medicals. While carbon dot used as an adsorbent because different type multiple functional group present on their surface, so we can use it as an adsorbent, as a novel adsorbent for the removal of contamination from the waste water. But due to their water solubility, create some difficulty during adsorption. So overcome this difficulty, we have to form carbon dot composite. This carbon dot, when combined with the matrix, then these are converted into the carbon dot composite. This matrix is different type, maybe different type. This carbon dot can be synthesized. Carbon dot and carbon dot composite we can synthesize from top-down approach or bottom-up. These are the method through which we can synthesize. These are my methodology. I used carbon dot, synthesized carbon dot from the plant waste material. I use S-guard seed for the synthesis of carbon dot using hydrothermal method. Then carbon dot composite synthesized after the synthesized carbon dot combined with the zinc oxide nanomaterial following hydrothermal method. Then these carbon dot composite combined again alginate solution for the converting proper novel adsorbent. And these are used for the adsorption procedure for wastewater treatment. These are the graphical representation of my research work. Here I used S-guard seed, and after grinding collect extract, then autoclave, collect after filtration, collect filtrate, then centrifuge, and after that collect supernatant in which carbon dot exists, and obtain carbon dot combined with the zinc oxide and convert into the carbon dot zinc oxide composite following the hydrothermal method. Then these prepared carbon dot zinc oxide composite again mix with the alginate solution for the forming bits for novel adsorbent. These are the result. Here UV spectroscopy. Carbon dot so excellent two-type peaks in 280 nanometer due to the pi to pi star transition due to the carbon double bond, and 374 peak due to the non-bonding to pi star transition due to the carbonyl group. Then B represent the zinc oxide UV spectra of the zinc oxide. Here highest peak obtained 287, and C represent the carbon dot composite UV spectra. Then these are the FTIR.
Yogita, direct shift to conclusion page.
Yes, sir. Sir, my work is going now. So I have studied some parameter for the removal of cationic dimethylene blue. And I studied some parameter like dye concentration, pH dose, and time and temperature. Here methylene blue percentage removal, 93% remove in a 20 minute, 20 ppm dye concentration in room temperature, 0.1 gram adsorbent dose. These are the phenomena of adsorption of dye from wastewater treatment. These are a reference. Thank you, sir.
Thakur sir.
Yes, it's very good work, good piece of work. I have one basic question. What is difference between science and technology? It is common question.
Yes, sir.
What is difference between science and technology?
Sir, science give knowledge.
And technology? It doesn't give knowledge.
Give knowledge, sir, but it provide facilities.
And what is difference between quantum dot and carbon dot?
Sir, quantum dot can be synthesized from any time, but carbon dot synthesized from the only bicarbonate material.
Okay. Okay, sir. It's okay from my side. Yes, sir.
Okay, sir. You asked quantum dot, carbon quantum dot, and quantum dot. Both are different.
Sir, quantum dot and carbon dot both are different things, because quantum dot can be synthesized from any kind, but carbon dot can be synthesized from only carbonous material. And carbon dot and carbon quantum dot both are same thing, sir.
What about graphene quantum dot?
So
You know about
also
graphene
carbon
quantum dot?
dot, sir.
Also carbon dots.
So it is also carbonous dot, sir, but it is not exactly carbon dot.
Okay. What about fluorine?
Sorry, sir.
Okay. Next, sir.
Yogita,
Ji, sir.
Yogita,
Ji, sir.
which TV manufacturing company using quantum dot technology?
Sorry, sir.
Have you gone to the various TV manufacturing companies, Samsung, LG? So have you heard about the quantum dot technology used in television?
Sorry, sir.
OLED. Have you heard about the OLED, OLED?
No, sir.
OLED TV, LCD, LED, OLED.
Yeah, sir.
Yeah, the same way to quantum dot. You just search the market. Samsung TV is providing quantum dot technology.
Yes, sir.
Okay, thank you. Now
Okay, thank
stop
you,
your
sir.
sharing.
Yes, sir.
Now I call upon Rida Rashid. Rida, are you available?
Yes, sir.
Okay, start your presentation.
Sir, is my screen visible? Hello?
Please share a slide.
Yes.
Your
The mobile screen is visible.
visible.
I think the internet problem is there, laptop problem or internet problem is there.
Sir,
Hence
is
sharing
it
from
visible
mobile.
now?
Yeah.
Okay, sir.
Okay, go ahead.
Okay. Good afternoon, everyone. I appreciate the opportunity to speak in front of you today. My name is Rida Rashid and I'm from Kashmir, India. I've recently passed my MSc and I'm planning to do PhD work. So the topic that I'm going to present today is a review on biochar, which I believe is a friend to the earth. So these are my contents. Introduction. So chemical fertilizers play an important role in the agricultural production. The amount of fertilizer input is more than half of the total input of the agricultural production. However, chemical fertilizers, they have a short time effect and easy loss and a low utilization rate, resulting in a large amount of loss and waste. Meanwhile, the environmental problems caused by the chemical fertilizers, such as the soil consolidation, heavy metal pollution, and water pollution, they are becoming more and more serious. Therefore, an environmental friendly fertilizer should be applied in agricultural production that would provide an easy solution to improve the soil quality and environment and to the environment, and that is biochar. So this review is based on the use of biochar and its impact on soil, crop, and the environment. So biochar traces its roots from the Amazonia over 2,000 years ago. It is a very porous and high carbon form of charcoal with multiple functional groups that could increase the nutrient retention, increase water retention, and enhance the soil fertility, and thereby promote the plant growth and the crop productivity. So its production. Biochar can be produced from crop residues, manure, municipal waste, forestry residues, dairy shed waste, bones, etc. And it is produced during the pyrolysis of biomass in oxygen-limited environment. Pyrolysis relates to the chemical breakdown that results in the liberation of pyrolytic gases, that is carbon monoxide, carbon dioxide, methane, that have a very high caloric value, and that makes them important fuel for chemical and energy industries. And what follows pyrolysis is carbonization. Carbonization is what comes next to pyrolysis. So this is how biogas is produced. So biomass, when subjected to high temperature in biomass, when subjected to high temperature in the absence of oxygen, that is pyrolysis, it converts into a gas, solid, char, and liquid products. The liquid product is also called bio oil or pyrolysis oil. So biochar properties. Biochar properties are affected by several technological parameters, mainly pyrolysis temperature and feedstock kind, which can lead to products with a wide range of values of pH, specific surface area, pore volume, volatile matter, ash, and carbon content. High pyrolysis temperature promotes the production of biochar with a strongly developed specific surface area, high porosity, pH, as well as content of ash and carbon, but with a low content of volatile matter. This is more likely due to the significant degree of organic matter decomposition. Biochar that are produced from the animal litter and the solid waste feedstock, they exhibit lower surface area, carbon content, and volatile matter as compared to the biochar produced from the crop residue and wood biomass, even at higher pyrolysis temperature. And the reason for this is the considerable variation in the lignin and the cellulose content, as well as in the moisture content of the biomass. So now moving on to the benefits. Because of the high carbon content, biochar doesn't break down over the time, which means once incorporated in the soil, one needs not to worry about the soil health. That means the effect is, we can say, permanent. And it has got, we don't need more maintenance. It has got less maintenance. That means its application is easy, and as it can hold the water, maintenance of the lawns and the crops becomes easy. It is environmental friendly because it has been studied that 1 ton of carbon locked away in a biochar is equivalent to 3 tons of carbon dioxide permanently removed from the atmosphere. Also, during the production of biochar, a renewable energy is produced as a byproduct, which can become a substitute to the fossil fuel. Improved plant health. We can say that biochar is proven to increase the health of almost every type of plant, thus increasing the productivity. And because of biochar's purity, it doesn't degrade. As I already said, it can become we can say it is a permanent improvement to the soil. And another physical effect that it has on the soil fertility, a good effect, that is biochar, it has a microscopic honeycomb structure that improves the aeration, water holding capacity, and the nutrient retention of the soil, and thus it helps the roots it helps the roots to hold the nutrients. So these are the benefits. Then moving on to the conclusion, biochar can have a tremendously positive effect on the planet, both in reversing the climate change and in providing products and services that the world needs. Thank you, sir. This was all about my presentation.
Thank you, Ridha. It was nice presentation.
Thank you, sir.
Jury members, you have any questions?
Sir, Thakur sir.
Hello. Yes, sir.
Please, sir.
Hello.
Yes.
Hello.
Yes,
sir.
Yes.
Yes, Singh sir. From my side, there is no question, sir.
Yeah. Okay, go ahead.
Excuse me.
Yes, sir.
Whether the chair will permit me to interact with the
yes sir. Yes sir. Sir, namaskar.
I am Lalji Singh from Indira Gandhi Krishi Vishwavidyalaya, Raipur.
Yes, sir.
Ridha, am I audible to you?
Yes.
Yes,
you're
sir.
audible.
Okay. as this production of biochar is a very costly affair, and it has really very tremendous scope in particularly the forestry sector and agriculture sector. So what is the sustainable way? What is the economical way, cheap way? Because commercial production is not yet being done in the country. So what is the economical way to get the biochar so that the researchers of the future can go ahead? You have given very good presentation, though I am not the jury member, but I appreciate your presentation. But I want to know.
Sir, thank you so much. I was not feeling capable of myself speaking in front of all the jury members and even the students, because I'm not a research student. I've just passed my MSc. So thank you so much. This means a lot.
No, it's hardly a matter. MSc students are being very bright and good, and they are the future of the country. And your presentation was, to my understanding, was very good. You explained the subject nicely.
Thank you, sir.
So anyway, you are the budding scientist. If you don't have the answer, no problem. But I appreciate your presentation.
Thank you so much, sir. Thank you so much. So biomass, I feel we can, government can help in, making small biomass, so these biochar plants, and we can, we can introduce new schemes, and young entrepreneurs can also, invest in that. I think that could be.
Okay. You try your career in this field. This is a very potential area.
Thank you, sir.
Yeah.
Thank you, sir.
I think Rita, you can write the email to sir. Basically, sir is very, I think, renowned and expert in this field. Okay.
Sir, it would be very kind of you if you could share the email ID.
Sir Lalisan.
Certainly, you can note down my, if you have pen and paper, right now
Yes,
you can.
sir, please. Yes, sir, please. I have.
You can note down my contact number
Even
or
you can share
mail
on
ID
chat.
also.
Thank you so much.
It's very simple.
You just check the
Lalji,
chat.
LALJI.
LALGI.
Dot. Singh, SINGH.
SINGH.
Numeral 2. At gmail.com.
Thank you so much, sir. Thank you
at
so much.
gmail.com.
Thank you so much, sir.
Welcome, Riddha.
Okay, any other question from jury members?
No. Please go ahead.
Okay, thank you, Rita.
Next.
Thank
you.
you.
Okay, now I have call upon Jyoti Patel. Is she available? Jyoti Patel. Okay, otherwise I jump to Shalini. Shalini is, I think, available.
Yes, sir.
Shalini, you just start your presentation. You have 8 minutes. Shalini, your voice is not coming. Shalini, your voice is not coming.
Rising human population, particularly when coupled with rapid industrial and economic development, is a major cause of
Shalini, again you are muted, I think. Shalini, share your presentation. Shalini, are you hearing me? Shalini, are you available?
Yes, sir.
Yeah, just start your presentation. Your screen is not sharing. Share your slide.
Yes, sir. Yes, sir. I'm sharing.
अरे जूम तो खुला हुआ है भाई।
Sir, PPT don't remove this PC.
उसमें क्यों जाओगे? अपना पेन ड्राइव लगाए हो तो जो है। पहले से इसीलिए बुलाया कि जो है
No issue, Shalini. You can try after the next one. If you need some time, no worry.
Sir,
No worry at
my
all.
slide is visible, sir.
Yeah, visible.
यहाँ से जो है लीव कर लो, जाओ वहाँ पे जो है मिक्रोफोन जो है गलत तरीके से यहाँ से मैं लीव कर दिए, वहाँ से जो है पिक कर लो। उससे कर दो, जो है उससे लीव करके फिर से ज्वाइन कर।
Shalini, you want to take some time? Shall I call the next one? Then you will start your fresh presentation. No issue.
Okay, sir. Okay.
Huh? Okay. Now I will call upon Sarabjot Kaur. Sarabjot Kaur, are you available?
हमारे वाले को जो है लीव कर जाओ, अपने से वो करो, जो लॉगिन करो।
जी।
Shalini, now just stop sharing. Now I will call upon Sarabjot. Then after Sarabjot, you again try it.
Yes, sir.
So just stop your sharing. Shalini, stop your sharing. And no worries at all. Just try after Sarabjot. Dr. Sarabjot, are you available? The name is showing.
Yeah.
Sarabjot. Dr. Sarabjot, are you available?
Before they start this session, he has already given the consent about. I think if you have any mobile number, then I think.
have a list in which Dr. Sarabjot's name was mentioned. Okay, no issue. Any other participant who was previously absent? Damini?
Sir, I am there.
Okay. Dr. Sarabjot is available. Please start your presentation. You have 8 minutes.
Sir, my screen visible?
No. Screen is visible. Slides is not
Okay.
share.
So now is it visible? My screen?
No.
No?
No. Yes. Your mobile version is visible.
Okay, and my slides now?
Yeah.
Yeah, is it there?
Yeah. Rotate the mobile. Yes.
Okay, so shall I start, sir?
Yeah. Sure. Definitely. Go ahead.
Yeah, so I'm Dr. Sarabjot Kaur, and I'm Assistant Professor, Government NTV College of Science, Raipur. And my today's topic is amine decorated polystyrene nanobeads incorporating a pi conjugated OPV chromophore for picric acid sensing in water. So yeah, I'll start that this picric acid basically is used in the synthesis of dyes and drugs and pesticides. And basically, this is making it very easy to enter the environment and basically pollute the soil and water and causing several concerns. Okay, so up till now, basically there are very multiple fluorescence-based sensor they are available, but the basic problem is that, for instance, here I'm showing this MOF-based sensor. So they have carried out their study in DMA, which is dimethylacetamide. Same way in one more report by Seng et al. And this Venkit et al. They are also showing this PA sensors, but in methanol and ethanol. So most of the reported sensors, they are reporting in an organic solvent. And the other problems is that when they are, even when they are showing in water, few reports are there in water too, but the basic problem is the selectivity. So they are facing the interference from the other nitro organics, or there are the interferences from the some heavy metal ions that are present in water, such as this four they have mentioned, like in bulk, like in copper 2, nickel 2, iron 3, and zinc 2. So they are basically, they are always they are present in water, and the picric acid sensing, they are the main interference. So what they are doing, what the scientists are doing, they are basically complexing this four metal ions with the EDTA to make a complex out of it. Like they are removing this prior to the sensing test for picric acid. So what basically we did is, in an attempt to overcome this limitation, so basically we have adopted two approaches. What we did is the covalent stitching of the fluorophore. This is the first thing, and the second is the surface functionalization, so as to basically improve the analyte sensor interaction via hydrogen bonding. And that is how basically we can have a better selectivity for these picric acid molecule. And also we have checked the interferences from almost 16 cations. And for device applicability also, we have casted a freestanding film. So this is the characterization of our polymer. And so this is the emission and excitation spectra. Also, the one more thing is that mostly this quantum dots and these upconverting nanoparticles, they are facing the issue that their emission intensity varies with varying condition of pH and temperature. So here we are showing that even at the pH range from 1 to 14, the emission remain constant. Also, we have measured the fluorescence intensity at a various temperature, and showing that there is no appreciable change in the fluorescence intensity at varying with varying temperature range. So this is the range of for the analytes that we have chosen for our study. Yeah, so this in order to check the uh, the selectivity of a sensor toward the picric acid, here we have carried out a fluorescence titration experiment, which clearly shows the selectivity of the sensor toward the nitrophenols, while no remarkable change is observed on addition of the other analytes. And this figure C also showed the marked disappearance of the blue emission from the polymer. Under UV lamp also we are showing this, and the same data is supported by the decrease in the excitation spectra. So yeah, here because in literature there were reports that the Fe3, copper 2, zinc 2, so these were the probable crucial cation that are present in water, and these have to be removed before carrying out the picric acid sensing. But in our case, we have observed no appreciable change in the fluorescence intensity in the even in the presence of these four cation, and also among this we have checked the other 16 cations that are crucially present in water. And meanwhile, also we have checked the library of anions that are present in the that might present in water, and they also none were found to have to affect the emission intensity of the polymer. Also, yeah, here I have not shown, but I've also checked with the NaCl. So here also in NaCl also no appreciable quenching was observed. So this clearly shows that this could be used for picric acid sensing even directly in a seawater. Okay, so basically we have studied a Stern-Warmer plot in order to find the mechanism of sensing, and the non-linearity in the Stern-Warmer plot suggested the probability of a four mechanism. So the first one is the ground state complex formation. The second is the energy transfer. The third was the inner filter effect, and the fourth was the photo-induced electron transfer. So here we have found that when we took the absorption spectra of polymer with a varying concentration of a picric acid. Here, what we found is a no obvious shift or appearance of new peak in the absorption spectra. So this clearly ruled out the possibility of quenching by a ground state complex formation between picric acid and a polymer. Also, what here we found that there is a appreciable spectral overlap between the absorption spectra of a picric acid or nitrophenols and the emission spectra of the polymer. So this indicates the possibility of a long range energy transfer. Okay, but what we did when we measured the fluorescence intensity at varying temperature, no appreciable change in the quenching percentage was observed. So this shows that this energy transfer is of a static type. So this is a static quenching. Also, when we plotted the three graphs together, we found that the absorbance of the picric acid and excitation spectra of the polymer or the sensor was in an overlap. Okay, and this clearly shows the possibility of an inner filter effect, because the basically this inner filter effect is the possibility this reduces basically the fluorescence intensity of a fluorophore, okay, due to the competitive absorption by the picric acid molecule, and that's why this non-linearity between this concentration is observed. Okay, so this is the comparison table where we found a table of comparison from a literature. So here we clearly see that this were mostly carried out in organic solvent or the mixture of organic and water solvent. Some were reported in a water also, but they were facing the interferences from the cation and anions. Also, they were suffering from the various pH and temperature conditions. Okay, but here we have shown that there is clearly no interference from this cation and anions. Also, pH and temperature also both we checked, and we found the non-interference from these different condition of pH and temperature. Also, we have used 100% water. Okay, so this yeah, so I would like to acknowledge our principal, Dr. P.C. Chauhan sir, and my HOD, Dr. Mishra sir, my PhD supervisor, Dr. S.K. Asha ma'am, and my lab mates, my colleagues, and CSI and NCL for the facilities and funding. Thank you so much.
Very nice, Dr. Sarabjot.
Thank you so much, sir.
Jury members.
Thakur sir.
Sir, I think it's okay, sir. We can proceed for the next.
Yeah. Already late.
Yes.
Okay, no question. No question. Okay, Dr. Sarabjot.
Okay, sir. Thank you so
Unshare
much.
unshare your screen.
Sure.
Now I will call upon Shalini. Shalini, are you ready?
Yes, sir, I'm ready.
Yeah, just start your presentation.
Very good afternoon. Very good afternoon, one and all. Myself, Shalini Topu. I'm PhD scholar, and Dr. Lalji Singh is my supervisor. I'm going to present on impact of land use on vegetation and soil carbon, net primary productivity, and nitrogen budget in tropical dry deciduous forest of Barnavapara Sanctuary. Background: rising human population, particularly when coupled with rapid industrial and economic development, is a major cause of global environmental change. One of the most visible types of change caused by human activities is land cover change. The conversion of land cover from one cover type, such as forest or grassland, to another type, such as agriculture or urban. Land cover change typically involves altering or removing the vegetation in the landscape. Such disturbances to the landscape reduce the capacity of a region's ecosystem to contribute to important biospheric process, including the terrestrial carbon cycle. The most common types of land cover change cause a net loss of vegetation from the landscape and disturb the underlying soil. This can result in a net release of carbon stored in vegetation and soils to the atmosphere, where it contributes to rising atmospheric carbon dioxide concentrations and potentially global warming. The destruction of tropical forest is continuing at a pace of more than 1% per year. However, much attention has been given to tropical forests due to their species richness, high standing biomass, and greater productivity. These are the objectives: to quantify the biomass, net primary productivity, carbon and nitrogen storage with natural forests and plantation forests; to categorize the ecosystems level net primary productivity, carbon and nitrogen cycling strategies in the natural forest and plantation forest; to assess the impact of land use changes on storage and sequestration carbon and nitrogen cycling in natural forest and plantation forest. Drivers of land use changes: fire, landslides, wind throw, and insect attack are the natural causes, and clearing, burning, logging are man-made causes. Consequences of land use change: interference in dispersal and migration process, altered ecosystem inputs and outputs, exposure of isolated core habitats of the forest, changes in diversity of flora and fauna near forest edges, decline in biomass near forest edges, and emission of CO2 and other greenhouse gases, as these mechanisms are responsible for the progressive erosion of biodiversity. This slide shows the study area, that is Barnava Para Sanctuary. This is a natural view of the view of natural forest, a view of teak plantation, species structure of tree layer in closed forest. The dominance is shared by the top 4 or 5 species, that is Shorea robusta, Cleisanthus collinus, Madhuca indica, Acacia catechu, and Diosporus melanoxylon, and the respective important value index is given, that is 44.815, 39.971. This slide shows the species structure of tree layer in open forest. The dominant species are Chloroxylon sweetiana, Cleisanthus collinus, Madhuca indica, Lagestromia parviflora. This slide shows the species structure of tree layer in degraded forest. More than half of the dominance is shared by the Terminalia tomentosa. The importance value index is 164.644. Species structure of tree layer of 10 years old teak plantation. Because it is a plantation of Tectona grandis, the dominant species is Tectona grandis, and the others are regenerated species. The density is 570 stems per hectare. And species structure of tree layer of 20 years old teak plantation, here the density is 410 stems per hectare. And in 30 years old teak plantation, the density of Tectona grandis is 280 stems per hectare. Diversity in various forest plots. The Shannon index is highest for closed forest, that is 3.45, and Simpson index is highest for 10 years old teak plantation, 0.98, and equitability index is highest for open forest, 1.15, and species richness is highest for closed forest, 5.63. Biomass on different sites. the biomass is maximum for closed forest, which is 220.76 ton per hectare, and is gradually decreased from open forest to degraded forest. And in teak plantation, the maximum biomass is for 30 years old plantation, followed by 10 years and 20 years old plantation. Mean fine root biomass, 10 for calculation of mean fine root biomass, 10 monolith of 20 centimeter is dug out, washed, and the received roots are oven dried and weighed. And the maximum biomass is for closed forest, followed by open and degraded forest. And in the teak plantation, it is maximum for 30 years plantation, then 40 years, and followed by 20 years, followed by 10 years old plantation. Net net production in different sites. The net primary production was measured by using the girth increments, and girth were measured for 2 consecutive annual cycles. It is maximum for closed forest, followed by degraded and open forest. And in case of teak plantation, it is maximum for 30 years old plantation, followed by 10 years and 20 years. Carbon and nitrogen concentration. Carbon and nitrogen concentrations are estimated using CHN auto analyzer. The samples of different tree components for all species were separately collected, and the composite samples were oven dried, grounded, and estimated for carbon and nitrogen concentration. This value is the mean of 20 trees. This slide shows the carbon storage on different sites, which is going successively down from closed forest to degraded forest. And the carbon storage is maximum in case of teak plantation in 30 years old plantation, followed by 20 years and 10 years. Carbon storage is calculated by multiplying the carbon concentration of the component to the biomass of the respective component. And in calculation of nitrogen storage, it is as same as the carbon storage. The nitrogen concentration is multiplied by the biomass of the respective component. And this slide shows the carbon sequestration in different sites. Carbon sequestration was determined by multiplying the net primary productivity with carbon concentration of respective components. And this slide shows the flux of nitrogen in different sites, which is maximum for closed forest, followed by open forest and degraded forest. And in teak plantation, it is maximum for 30 years old plantation, followed by 10 years and 20 years.
Yeah, conclude your slide.
The carbon and nitrogen storage in soils of forest and plantation sites reveal the direct relationship between C and N, storage and vegetation. Therefore, closed natural forest sites and oldest teak plantation site stored more carbon and nitrogen in soils as compared to open forest, degraded forest, and young teak plantations. Therefore, it is concluded that natural forest should not be brought into plantation program until they are not highly degraded. Study emphasizes the impact of land use on vegetational properties, net primary productivity, and carbon and nitrogen budget of the forest ecosystem. Thank you for patience hearing me.
Thank you, Salini.
Thakur sir. Sir, we can proceed, I think. Okay.
Okay, no question. Okay. Now unshare your slide, Salini.
Okay, sir. Thank you, sir.
Okay, now I'm seeing that Khushbu Sahu is available. Khushbu, are you available?
Sir. Yes, sir.
Yeah, you have to mention on chat that I am available. Kindly permit me. You have not mentioned anywhere in your chat.
No one to ask you question.
Hello. Sir, I'm ready. Sir, I'm ready to present.
Go ahead.
From your right, there
Okay.
is one student, girl student is speaking, and
Hello.
your photo
Kindly
is.
microphone. Kindly mute your microphone, please.
Chandra, sir.
नहीं फिजिक्स में
अच्छा,
टेस्ट फिजिक्स में
Sir, can I start?
Go ahead. Go ahead. Go ahead.
Yes, sir. Sir, good afternoon, respected professors, research scholar, and student. I am Khushbu Sahu. I would like to present my work here. My title is Spectrophotometric Determination of Streptomycin involving green chemistry and its application. So it's not in a full screen. Okay, these are 12 aspects of green chemistry. The green chemistry, the design of chemistry, the design of chemical process, product and technologies that reduces or eliminates the use and generation of hazardous substances. The preparation of silver nanoparticle. I have taken dried leaves for formation of aqueous extract and adding silver nitrate dropwise for 30 minutes and further stay my solution for again 30 minutes to get pure silver nanoparticle solution. It is used to characterization by UV visible spectrophotometer. The compound Eclipsa hispidia burm and monkey tail, I have taken this plant in my work. The experimental section, you can see the increasing concentration of silver ions and the color is changing. The streptomycin, it is my compound. It is used to be detection and determination. The toxicities of streptomycin. Characterization. I have used UV visible spectrophotometer in my work with the 400 to 430 nanometer ranges. The absorption spectra, the graph you can see, first graph is showing calibration curve of the pure silver nanoparticle and second is calibration curve for the determination and detection of streptomycin with a range of 200 to 800 nanometer using pure silver nanoparticle as a colorimetric sensor probe. Here you can see the first is for pure silver nanoparticle and second is I have taken various concentration of drugs, streptomycin with adding pure silver nanoparticle. This is calibration curve. I have got strict line in my concentration of streptomycin. These are the characterization of first is FTIR and second is SEM image of synthesized silver nanoparticle. We can see the application of my recommended method here in environmental sample, soil, water and leaves I have taken in different area and recovery percentage you can see that 99% higher percentage in recovery table for streptomycin I have got. The conclusion is the number of methods are available for the detection and determination of organic pollutant, but they are costly, sophisticated instrument which require trained staff to handle them. My work is very easy and it can easily available and the less toxic. I told again I am saying that I am using less toxic reagent in my work. The method developed may be applied for the determination of pollutants in various environmental samples like vegetable soils and water bodies, etc. These are references. Thank you, sir.
Nice for Khushbu.
Thank you, sir.
Yeah, jury members, you have any questions?
In a green chemistry approach, greener method, the
Yes.
atom economy approach is there. What does it mean?
Yes, sir.
atom economy, the sir, I will read about it.
Okay, no problem.
Yes, sir. And all 12 aspects I'm try to cover all aspects of green chemistry in my work.
Okay, no problem.
Sir, is there any next question?
No, from my side, it is okay.
Very simple question. Who is called the father of green chemistry?
Sir, Paul Anastas.
Okay, nice.
In 1998, he's discovered.
Okay, any other question? Anyone want to ask any question? Khushbu is ready. Okay, no question. Khushbu, kindly unshare your slides.
Thank you, sir.
We have total 6 absentia. If anyone absentia is now available, please raise your hand or message me. Or shall I read the name of the absentia? The first one is Damini. Second one is Anju Jha. Third one is Dr. Sandhya Dikshit. Fourth one is Archana Sahu. Fifth one is Sakila Banu. Sixth one is Jyoti Patel. If anyone from these names are present, please message me or raise your hand. Otherwise, I have to end the session and request the organizer to start your. Yeah, I hand over mic to the organizing committee.
Thank you, Dr. Tejosi.
My pleasure, my pleasure.
I am very thankful to all resource persons and jury member, especially chairperson of the day, that is Dr. Tejosi, for giving a whole day for this successful technical session. So again, I am very thankful. For tomorrow, we have 2 lectures, one from, I think, Dr. Rameshwar Adhikari from Tribhuvan University, Nepal, and another one is Surya Prakash Singh from Indian Institute of Chemical Technology, Hyderabad. After that, 7 poster presentations. So I would like to say about the participants, please, all are present at 10:50 because program will start at 11 o'clock. And after oral poster presentation, lastly, electric function. So chief guest of electric function is Dr. Sharaf from Pandit Shankar Shukla University, Raipur. So thank you again, all. Namaskar, Jai Hind.
Sir, can we have a group photo?
Yes.
Screenshot.
I would like to ask all participants, just they unmute the camera. Just we have a screenshot. Please, it is requested to all. Just unmute your camera. All participants, please. Again, I request all participants, jury member, chairperson, and faculty members
And please take a screenshot from your side too, so we will get the best picture. Thank you.
Key members को special thanks. Dr. Tejas, आपको special thanks for sparing
Thank you, madam.
your valuable time, a long time with us.
My
Thank
pleasure,
you.
my pleasure, ma'am. My
Thank
pleasure.
you.
Thank you.
So thank you, Singh Saab, for providing us opportunity for this wonderful webinar, and all the participants, they have presented nicely, sir, and you have organized in a nicely manner. So
Thank you, sir. Thank you.
yeah, it was a great. Congratulations and best wishes for future endeavors, sir. Thank you very much.
Thank you, sir.
Singh Saab and whole team, Asthana madam and all the team members.
Okay, thank you.
Thank you, sir. Jai Hind, Jai Johar.
Jai Hind. Bhavna,
Yes, sir.
हो गया screenshot?
Yes, sir.
Okay.
Okay, sir. Okay, have a nice day, everyone.
Dr. Tejas Joshi, namaskar again. Take, okay.
Jai Hind, sir.
Jai Hind.
Jai Hind,
Thank
ma'am.
you.
Thank you.
Sir, shall I end the meeting?